LZ map and LZ reduce, I can then manipulate the data that's being requested and return something completely different back to my verification, ultimately to have it executed back to my contract. So what this ultimately builds to is this ability to essentially initiate a request from any chain and bring specific state back on chain that you want. The example that we'll be going through today is actually fetching live Uniswap ETH to USD pairs from multiple different blockchains, aggregating that price off chain using our DVNs, and then bringing it back on chain as a request. For this workshop, if you go ahead and scan this QR code, it'll give you a Linktree link. This Linktree will have links to the example code that I'm using, to the relevant documentation about Layer 0 read, and then also just more information about Layer 0 in general. Cool. We're going to jump into the code example, and I'm going to show you exactly how to get started. I have two windows pulled up here, one that I've already deployed, and then one that we can base our contract off of. The first thing that we're going to do is go ahead and use Layer 0 CLI tool to get started. The simplest way to do this is running LZ enable read example equals 1 in your environment, and then this command npx package, create LZ OAuth at latest. What this command will do is basically create a prompt for you to build a new repo. In this case, I've already created one, but I'm going to call this my read2. It'll give you a list of contracts that you can start from. There's OFT, OAP, ONFT, some upgradable variants if you want. In this case, I'll do OAP read. This is the one that has all of the read contracts installed. Pull all the dependencies down that I want to use, et cetera, et cetera. In the meantime, what's happening in this contract is that OAP read is just a simple example contract based on this standard, OAP read here. OAP read you can find once these dependencies get pulled in node modules, but in the meantime, I actually have them pulled up for us here already. We can go ahead and bring this contract up. I'll actually walk you through live really quick how this Uniswap v3 quote demo works. So at a high level, I'm going to pull terminal down really quick and just get all this stuff sorted. Perfect. The Uniswap v3 quote demo is just an extension of OAP read. OAP read itself is just an extension of OAP, the base cross-chain messaging contract. The only difference that we're actually doing is setting up one function, a read channel. The way that read works is that you can define specific messaging channels that you want to send to, and then use them for constructing your data requests and compute logic. In this case, looking at this contract, I've defined a couple main constants. First, just a chain config with the Uniswap v3 quoter address for the target chain that I'm looking for, the token in address for wrapped ETH, the token out for USDC, and then also just defining these constants here directly in the contract. You can see here that each chain has an endpoint identifier that I'm using. In the constructor of this contract, I'm setting up the Layer 0 read channel. The channel ID is just an arbitrary identifier for where I'm going to be sending to and how I'm going to be reading from. And then for each of these chain configs, again, just pulling all of the relevant Uniswap v3 pool contracts for iQuoter v2 and setting them up here. The way that this read average Uniswap price function works is that we're essentially generating a read command and then passing it to the normal Layer 0 send method that you would use. The only difference being we're passing the read channel as the endpoint ID and a command as opposed to our Layer 0 message. Under the hood, the way that get command works is that it is a standard function that you want to set up within your application. This get command will basically define the number of call requests that you want to have executed cross-chain. In this case, I'm just using the number of pairs that I've been putting, 3. And I will define basically as call data the type of params that I want to essentially use as call data on these target networks. Here I'm using the iQuoter v2 from Uniswap v3, quote exact input single params. I'm encoding this as call data for this function selector, and then generating in this for loop the number of read requests for each of the chains that I want to read from. Under the hood, the second thing that I'm doing is defining a compute request. The compute request is basically how am I aggregating all of this data once it's returned. There are a couple compute settings. If I do, for example, compute setting 0, this is LZ map. If I do 1, this is LZ reduce. Let me just fix that, not LZ meow. And then 2 is LZ map and reduce. Again, you can look for these function methods wherever you like. In this case, we're looking back on the same chain at this address. The function LZ map is basically deconstructing for each response what is the actual output. So in this case, we're getting the response from the Uniswap contract of 4 main return types. The only one that we care about is the actual amount out that's being returned. And then LZ reduce is defining, once we have all of these aggregated responses, you can see here we're getting a bytes array of call data for responses. We're taking all the responses that we get from each of these chains, aggregating them, and then just doing a simple average to basically get the average amount out from each of these networks. And then finally, the only thing that I'm getting back in LZ receive is what is produced from the ABI encoded argument here in LZ reduce, delivered to my contract on chain. So high level, walking through this again, we construct in the send call a command. That command is comprised of both the requests for data that we want to go get on different target networks, the call data for those chains, and the actual address that we're quoting from, and then some compute settings. In this case, looking back on the source chain for LZ map and LZ reduce to go and aggregate this function logic. And what's cool is that these functions will get executed off-chain bar DVNs that we've configured, and then only this final ABI encode from LZ reduce will be delivered as a message to LZ receive. So a lot I kind of went over there. Let's actually look at this kind of in action a bit more. We're going to zoom out here. I'm going to pop into Arbitrum. First, I'm going to query this quote price for the transaction I'm going to do, in this case in Wei. What I'm going to do from here too is then grab this Wei price, go to Ether converter just to simplify this process a bit, punch in the conversion to Ether, then go to write contract, read average Uniswap price, throw the amount in, don't have any extra options that I want to add. We'll write on the block explorer this call, hit confirm, and what will happen here is it'll generate this transaction on Arbitrum for us that got confirmed basically instantly. And then we can go into layer 0 scan and actually see what's happening under the hood here. Inside layer 0 scan, this basically just serves as a record of all transactions processed by the protocol. It might take a second for it to index and come through. Here we go. You can see that we have a request transaction hash from Arbitrum, and we're waiting for the response transaction to land. You can see here that we have a request payload that we generated. There are some decoding instructions that you can follow from the documentation about how to decode any incorrectly constructed calls that are made here. But what will basically be outputted back on chain while we're waiting for this one to land is the aggregated price from all of these different networks that we're reading from. One of the things that I've done here as a transaction already is reading the average price earlier, I think 2 or 3 days ago. We can basically see here that we're getting executor fee paid, DVN fee paid on the send side and the packet sent event. And then from the overview section here, if we go and add this transaction to Tenderly, this one's already been indexed. We can see the destination here. Open it up, go to our logs, and we can see the aggregated price for ETH a few days ago was 3307, looking directly from all of the Uniswap pools that we have configured. So what this basically enables you to do is take data in the form of a call data request that we saw here, aggregate from that call data request the responses and return values that we get on chain from any type of view or pure function or public state variable that's on a destination blockchain, and then use the LZ reduce and LZ map methods to basically take all those requests that we want, aggregate them down to one final response payload, and then deliver that response payload to LZ receive. So yeah, I hope this gave you kind of a good overview of how Layer 0 read works. Now open any questions you guys might have about the protocol, about cross-chain messaging, read messaging, things like that. Sure. Yeah, sounds good. Yeah, thank you guys. Oh, I have to jump on you guys.
Is it up?
Yeah, just a second. I think I need to do it here.
Okay. Yeah.
Did it work?
make sure you have the screen share on.
I'm not sure. Like I want to share like the full screen out. I'm not even. Yeah, my cursor is not coming. Oh, here it is. But yeah, I think it's.
You have to open to tab.
What do I? Mirroring.
Yeah.
I think I have to change the
Mirror.
mirror.
Yeah. Yeah. Now should be fine.
Oh, มันไม่ขึ้นหน้าจอนี่เหรอ ใช่ มันต้องไปที่ display you go to display แล้วก็เป็นsetting display and setting
This place looks.
ก็ต้องเป็น mirror นะก็คงจะ
Photos just take the.
do you open on for setting
Yeah, I am mirroring. You can stop that, but this is the main display. Mirror. This is not good.
Yeah, there we go.
Yeah. 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 Hey everyone, GM. So let's get started with the push protocol workshop. In this workshop, I will basically be telling about push, how you can use push, how can you use our SDKs, and basically what are the use cases on which you can build. So yeah, let's get started. So the first thing we want to basically see out is what is the problem in Web3. And we are going to talk here like about the very low problems, not anything which is very much complex. So this will be like a beginner-friendly workshop. So any action in Web3 uses a lot of interactions. If you have used any website, you need to create your own wallets, you need to pass your own seeds, and you need to store them securely, right? We all have done this. Same goes with the user apathy, that a user need to know everything about Web3 once he's getting into Web3. Even now, if we have like AA's chain abstraction, but these are not up to the mark. The next thing we have is lack of communication. So let's try to explore that more. So DAOs are not able to talk. I'm sure folks here are a part of any DAO, but the moment any DAO proposal happens, you have to go there and see if there's a new proposal or I have to vote. It is not the other way around where a DAO comes to you and give you all the things which you need or all the proposals which you need. Same goes with DeFi. How many here just got liquidated after something crazy happened in a market? And you didn't even get to know that, yeah, this happened because it was just like in a minute of 5 to 10 minutes. And it could have been saved if you got notified that, hey, you are about to liquidate or so. Same goes with NFTs. Let's suppose that a very famous NFT guy just posted his NFT and you were not able to take part in the airdrop because you didn't know that. So these things can just be targeted out using push. So how can push help you here? Let's get started with that. So it all starts with a notification. I think all of us, from a web to background, we kind of have like notifications for everything. You get up in the morning, you get notifications from your famous social media apps, you get notifications from your food apps, etc. The same goes with Web3. Web3 too needs notifications. So that's what we are building. And even in notifications, we have like an open communication layer. That means anyone can join into the network. We have notifications which are dynamic. That means you can change those notifications according to your requirement. Even if you want to have some kind of CTAs into build, and even if you want to have any images into your notifications, that can also be done. The next thing is these are multi-chain, so it does not matter if you are building on Ethereum, you are building on Arbitrum, Optimism. These can be multi-chain. Gasless, of course, if you are sending 100,000 notifications per day, you don't want gas to be there. And platform agnostic is something which we are working on. So you can send out notifications on mobile apps, on web apps, on even like as a MetaMask snap, so that it is interoperable and can be seen everywhere. So that's basically about notifications, but we also have our chat systems. So let's discuss about chat. So we all here are from Web3, but I'm pretty much sure that you might have joined like 100 Telegram groups or even like 100 Discord servers. So mainly currently also in Web3, the communication system or the way we interact with the community is using the Web2 systems, and Push Protocol wants to change that. So what we have is push chat. That means you can chat with any wallet and you can integrate it into any dApp. This chat is completely decentralized. We don't hold it on our private servers or anything. Data is stored decentralized, I believe, on IPFS. We even have like group chats, etc. So let's suppose you are building for your community and you want to have private groups. You want to have public groups. You want to have groups which are gated using NFTs. You want to have gating using ERC20 tokens. So you can do all of that using push chat. And it's pretty easy. And I will just do a speed run here where I can show you how you can do that. But yeah, it's like a matter of 5 to 10 minutes, I believe. So yeah, let's get started on that. So we will go to our push dApp and let's try to see from there. So let's do our demo of notifications first. So one of the things which you need to do to send out a notification is create a channel on push. Creating channel is quite simple. What you do is you add a channel name, you add a channel category, some description, you upload a logo, and then you stake some fees. For creating a channel, it's like 50 push tokens as a fees. But even in this hackathon, if you want to use like a staging environment or testnet, you can just do that, and you can get the test tokens for free, of course. So I'm not going to display here how you can create a channel, but usually just follow this route that follow our docs and so. But it's quite simple. What we are going to see here is an example of how you can use push channel to send out notifications. So let's suppose there's a crazy market going on, and you are checking like what's the price of ETH like every 5 to 10 minutes. So you are just going to CoinMarketCap or CoinGecko and just checking the price. What if you get notified about the price of Ethereum like every 5 minutes, or according if Ethereum went up 3% in an hour or went down 3% in an hour or so. So we have something which is called price tracker, and I will just demo that out. So yeah, let's jump into the code. Okay. I believe this is visible now, but I have like a very simple script here. So what I'm doing is I have like an EtherScan API, and it does nothing. It just gets you the price of Ethereum and console logs it. So let me just run it out to show you. So yeah, we are running the script, and see, we got the result. What is the ETH price in USDT? Now what we want to do here is we want to basically add push notifications to it. So yeah, let's try to do that. What we will do is we will go to our docs. It's push.org/docs if you want to go to that. And the first thing which we need to do is initialize a user. So that's step number 1. So what I will do is I will just copy paste this. Let's just copy the initialization part. And I will just drop it here and we'll edit it later. So pasted it here. And yeah, let's change this. So this is the part where we kind of initialize a push user, but I will just paste this data here. Now, as you can see, we don't have a signer, but let me just add a signer here. So import ethers, and let's create a signer first. Yeah, and just for the private key, I already have like a private key in my ENV. So you create a channel and then you get its private key. Just export it out from the MetaMask, and then you are just good to go. So I have the private key here. Now my user is initialized, and I can pretty much see that here. What I need to do here is I will just send out a notification now. So go to send notification, and you can just see it's a very simple function call. I will just drop it here, and I will console log this out. And let's give it the ETH price notification. ETH price. ETH price R. And let's change it to a dynamic one. So let's do this. And yeah, I just need to grab the result.response from here. So yeah, this can be response.data dot result UST. Yeah, and let's save this, and this should just send out a notification on our environment. So as we can see, we are waiting, and yeah, now we have sent it out. And even if you want to see that notification out, it should be visible in our inbox. So yeah, here we can see. We have got the notification for ETH price. I've been testing it for a while, but yeah, it's that simple. So you can do the integration in just like 5 minutes. And now we will just do, we will see how you can basically integrate push chat. So let's move towards the push app and let's go towards chat, and where you can see that we have like a system here that you can just search for any address, and even like if somebody tries to chat with you, it first lands in your request box. So you first need to accept and then you can chat. In this example, I will basically show you how you can create a bot in like 5 minutes using push chat. But even if you are looking for group chats, you can basically create a group, add a group name, add a group description, add any kind of gating in your group, whether you want to do an ERC20 gating, ERC721 gating, etc. But yeah, let's go with a demo for the push bot. So what I'm going to do is I have like a address, and let me just search it out. Yeah, so I have this address which is 0x2d, and basically I will try to chat with this particular address. So yeah, I have like basically I chatted this before, but let's try to do the bot demo as of now. So let me go to the index.js. Let me increase this. Yeah, now it's great. So again, this is a very simple script. As you can see, what we are doing is we are just taking a signer from ethers, and this is basically the private key of this particular address, which I'm going to create a bot out. So yeah, this is quite simple. And let's see from our push docs what we need to do to send out a push chat. But we will go to the docs. We will explore out the section for push chat. So we will go to chat docs. First step is initialize your user. So I'm just going to copy paste that. And yeah. So we just imported like push API from our docs or from our SDK, and we are using it out. So we have the user initialized, and what I want to do is if the bot receives any message, he just returns out the response. So for that, first you need to do is you need to stream your chats. So let's search for stream chats option here. Yeah, there it is. So I will just copy paste this, and this is where we kind of just listen for the socket events. So we pasted out all of this, and if you want, you can just understand it, but I'm basically doing like a speed run here. So you are listening to like different events here. One is for chat, you are listening for notifications, connection, etc. What I will do is I will make it much more simpler. So on connection, we will receive just a socket connection. On receiving any chat message, we will just log that message out. And same for like all of the above. But yeah, at this point, let's start our server. So we'll do just an npm start. And as you can see, our push server is kind of connected. Let me also just see which environment I am on. So let's do prod. So I will display this out on our production environment, but I initialize my user on production. I am streaming the chats, and if this bot basically get any chat, it should just console log here. So let's try this out. Our bot is ready, and we should see first like this is connected. But on our production dApp, I will just try to send a message. Hey. So yeah, I think it went. Let me do it again then. Yeah, we have like received the event here. So what I typed to the bot was hey, and we returned it out on basically our backend. But what we want to do now is whenever we receive a message, we just return out something else. So what we do is if message, so you can see the message object here, right? So you just do if the message dot origin equal to other. So message dot origin equal to other is someone else is sending the message. And here what I want to do is I want to revert a message. So I want to return back or basically I want to reply. So what we are going to do is go to our docs, search for how you can just send out a message. So click on send message, copy this thing out, and let's just paste it here. So what we are doing it, we will be sending out a message. Where we want to send it is basically we want to revert back to the sender. So it will be like message dot from. And yeah, it is of type text, but we can just change the text and do it. How may I help you? Yeah. So let's do this, save this out, and yeah, our server is running fine. Now let's try to send out a chat message. Yeah. Hey bot. So we are sending out this message, and at a later point of time, we should just receive out another message. So yeah, even if we look at this, we received out a message, and this is the message we returned back to the user. So this origin self means that this was the message which was sent by the bot itself. Yeah, and even you can see it here, or maybe you can see on the refresh. But yeah, that's how it really works. So in a matter of like 5 to 6 seconds, you can just see how push chat or push bot can be integrated out. Let me unlock my profile. Yeah, confirm. I will just reload this, and at the very end, if I should have like a message of hey bot, and yeah, how may I help you? So this is how you can just integrate. I have done this on push chat. You can do it on your UI. You want to build a Telegram out, go for it. You want to build a Discord out, go for it. You can do it in groups. You can do it as a one-to-one chats. Support groups can be one of our like good reasons for it. And yeah, basically it is endless, right? You can do anything out with notifications. You can do anything out with chats. So yeah, I think I'm pretty much done with my workshop. So if you have like any questions, I'm up for it. Yeah. No? Yeah, sure. Sorry? You can do, yeah, okay. You don't need actually a server. You can do it on a UI. I've just displayed it out how you can do it if you have a backend server, but you can absolutely go for a UI. You can even use our UI components. You can do this on a React or a Vite or a Next app if you want.
Is there a dashboard to like control those push notifications for mobile devices?
So you can basically see out notifications on our app. You can see out on MetaMask using push snaps. We even have like browser extensions, and even we have like UI components which you can directly import on your UI.
Thank you.
Yeah, thank you so much. Even if you want to interact with me, I will be here around here or around the booth. So yeah, thank you everyone.
And you should do the screen mirroring things, and you should be able to see it here.
Oh, okay.
settings. Yeah. Wait, let me set it up and then I'll come.
Where is it?
Wait. There should be a like to mirror the display. I don't have an Apple, so I wouldn't know. Yeah, mirror. Last one. Yeah, there we go. Right?
All right, cool. So today I'll be talking about ETHGlobal. What we're building is what we call the Universal Confidential Computing Network. So today all the L1, L2s have one thing in common, is that they're complete transparent databases. We do believe that there needs to be a minimum confidentiality in order to drive mass adoption. So if you think about using crypto as your bank account today for payroll or just your savings account, everything is transparent. And this is quite inconvenient because this is not how Web2 works, right? What if you need to be able to hide your wealth? This is something that you just cannot do today in crypto. And then institutions and enterprises are still having a hard time entering the space. They have trade secrets. They have essentially information that they have to keep confidential. And then lastly, there are just a lot of use cases that wouldn't make sense without any confidentiality. So you can think of the card games, private voting, blind auction. So we utilize a cryptography called FHE. That stands for fully homomorphic encryption. By show of hands, how many people have heard of this term before? Okay, great. So for folks who are non-technical, the idea is that you can encrypt data, but also compute on top of it without having to decrypt. So when you apply FHE to the EVM, what this really means is that you get to have encrypted data types, but also encrypted operations, such as additions, multiplications, divisions. And we recently released a research paper with Circle on this topic of confidential ERC20 framework. And so the finding here really is on 3 points. One is on the flexibility of the decryption rules. The second one is on composability, which I'll mention a little bit more, talk a little bit more after. And then lastly, it's around this idea of programmable transfer rules. So the idea of composability here is with this basic primitive, a confidential ERC20, you are essentially able to build other things on top. So imagine being able to leverage the confidential amount and then cast a private vote, or use it for private payments, or use it for private lending. We are actually utilizing a couple different cryptographies to achieve this. So, ETHGlobal really is a combination of MPC, ZK, and FHE. These three cryptographies are utilized for very different purposes. So MPC here is only used for decryption. And so essentially there is a private key and public key pair that is essentially encrypting this entire system. But this private key never exists because what's happening is this MPC network generates this key through distributed key generation. And so you can think of this having as its own network. Essentially, if you need to decrypt something, every single node needs to do partial decryptions and then to recreate the plain text, right? And then on the compute side, we're utilizing FHE, which allows you to do state transitions over encrypted data without having to decrypt. And then lastly, the ZK part is to make sure that every ciphertext is not malformed, and then that the user also knows what the plain text is, because else someone can just copy paste your ciphertext, deploy it somewhere else, and then decrypt it, right? So with this, we actually believe this is the next frontier. It's the next frontier because you are now able to enable new use cases that weren't possible before. So if you think about gaming, there are just a lot of new types of games that you could be enabling with confidential compute, asset management, DeFi, and also infra. So just a couple examples, right? So in terms of confidential ERC20, this is probably the most basic example, just to explain what you can do here. Today, your balance is completely transparent. It's just a mapping of address to a plaintext integer. What if you want to hide your balance, right? So this is where having a encrypted data type like EUINs allows you to hide your balance. So here, I can directly encrypt the amount of money that I have, and when Bob sends money to Alice, what you're sending essentially is an encrypted amount, right? So this, you can see here, there's the EUN64. What's interesting about this is, the flow of funds is actually visible. It's only the amount that's being hidden. So it's very similar to Venmo or Revolut, that experience that some folks might be familiar with in Web 2. And how does this work, right? So how are you able to transfer a confidential amount without actually knowing what it is? So this is where you can actually write conditionals over encrypted data without actually using like a typical if-else statement. So the first line of code here, you're checking if the amount you're transferring is less than the user balance. And so you do this over FHE, where by doing tfhe.le, standing for less than or equal, you get an encrypted Boolean that basically could be true or false. And this is what you get is this variable can transfer that you pass it into this conditional multiplexer. So what this is really is you can think of an alternative to like an if-else statement. If the condition is true, you will return the encrypted amount. If it's false, you will return the encrypted 0. But from the outside perspective, transfer value is going to be encrypted, right? So now what you do is you add this transfer value to the recipient total amount, and then you also subtract it from the sender. So if the value is 0, essentially nothing happens. You just end up transferring 0. If the value is correct, then you end up transferring the actual amount. So another big use case here is also in gaming. If you think about today, there's no fully on-chain poker game. The reason why you can't do this game is because poker is a bluffing game. Without confidentiality, this game would basically make no sense. And so with FHE, you can actually generate a stream of randomness over encrypted bits. And so this is where you can call a simple function that generates additional basically integers that are hidden by default, right? So this is something that Chainlink would not be able to provide because your typical VRF is plaintext, but here you need to have a confidential integer here. We actually built this game roughly a year ago in New York, actually at ETHGlobal as well. And this is a fully on-chain mafia game. So another name for this game is Werewolf. The idea of this game is that you can have a secret killer, detective, doctor, and villager. And it's a bluffing game. Basically, if you're the secret killer, you have to pretend that you're not the killer throughout the entire game and try to last as long as possible. And the role of the other players are to basically figure out who this imposter is, right? So here again, because you can generate the hidden roles fully on chain using the randomness, you can also hide the roles. This becomes super easy to build. And also this is a multiplayer game, so using FHE and it becomes a lot easier because you can use the blockchain layer as the coordination layer. If you're to try to build this game using something that's more off-chain based, maybe like ZK, it would become a lot more complicated because then you have to build off-chain tooling. You have to think about state coordination across multiple players. But here, because everything happens on-chain, we built this in less than 30 hours. So yeah, if you think about games today in crypto, they could actually be a lot more fun than they are today. And this is because if you think about all the game mechanics that exist in Web 2 that actually make a game fun, require some kind of hidden information, right? So either I have to hide the player stats, the amount of gold that I have. And so here you can imagine a new game mechanic where the player stats are actually hidden. And so if you trigger some kind of battle mechanism, you can multiply the player stats by some kind of on-chain randomness and settle the battle, right? So this is where, for us, we do think gaming is a very, interesting vertical here that we can definitely expand and just have people build novel primitives and game mechanics. Identity is another one. The reason why it's also very impactful is because today all the DIDs are completely static. You would KYC with someone like Binance, that will basically send you a soulbound token that says, okay, you're over 18, you're in Europe, you have a good credit score. However, this is all public, right? What if you don't want all this information to be public? So what you can do with FHE is what we call dynamic DID, which the idea is I can actually encrypt your credit score and store it directly on chain and selectively reveal information. So the reason why you can do that is because with FHE, you can also do comparisons, right? So you can do a FHE.greater than. So I just want you to know that I have a credit score over 700 and nothing else, right? And this credit score can change over time, right? So it makes sense to have a identity layer that gets updated and where people can query different insights, and this insight could change over time. So other examples could be your geographic location, your age, and this is very similar to how Web2 works, right? You use your Google Auth to connect to different applications. You say, I want you to access my contacts, but not my Google Drive or my calendar, right? And this is kind of like missing user experience that we have in Web3, which everything is public. But what if, for a casino dApp, I just want you to know I'm over 18, all these other information should remain private. DeFi is very interesting because in the case of a private AMM, if the amount you're trying to swap is hidden, essentially nobody can front run you, right? Because they don't know, necessarily what the slippage would be and what the arbitrage opportunity could be, right? I mean, they could try it, but they're taking a lot of risk by trying to sandwich attack you. So, you do get MEV protection by default. And I would also say, I would urge people to think about other novel DeFi mechanisms. So let's say, confidential lending, where, today there are attacks where if I know you can be liquidated by manipulating the price, I can actually do it, right? But what if you hide the liquidation threshold? Then it makes it a lot harder for a hacker or attacker to basically try to gamify the system. And so this is actually a problem that actually happened in the past where people will manipulate the price oracle to get whales to get liquidated, right? So there could be more interesting things you could do here around private DeFi. Private voting is a very good example of how a shared private state is useful. Here, when people cast votes, they directly interact with this smart contract layer. There is composability. There is the ability for you to directly, cast the votes and do the tally directly on chain. And again, if you were to do this, using something like ZK that happens off chain, then it becomes a lot more complex to coordinate the states. And because ZK cannot do state transition over private data, there could also be information leakage. So we are compatible with existing Ethereum tooling. If you are a Solidity developer, you can get started within 20 minutes. So you can use Hardhat, Remix, MetaMask. And I would say, for anyone who has experience building Solidity, all you really have to learn are the new syntaxes. And also this slight different way to write conditionals, which is, select. And we support a pretty wide range of operations, comparisons. So you can do divisions, you can do right shift, left shift, bitwise operations. And yeah, it really means that you can build a lot of things beyond just simple payments. If you want to build DeFi, gaming, it's really up to you to unleash your creativity and then create novel primitives and also experiences for the end user. Just from a high level, the way this works is, there is a JavaScript library where you encrypt data, all the inputs. And so the way data is encrypted is called ciphertext. So you have data padding, some noise padding, and some noise. That's sort of the structure of the ciphertext. So you generate that on the front end, and you pass this on chain as an input param. And then from there, you can cast this into different types, like a EUINT8, 16, 32, 64, encrypted address, or encrypted Boolean. And so yeah, we have a 10K bounty. There are 3 tracks. One is open innovation. So here we're very flexible. If you can come up with novel primitives around DeFi, identity, governance, this is kind of what we're trying to push people to explore. And then it is pretty greenfield opportunity because these primitives don't exist over FHE, and so there is an opportunity for you to be the first one here. Second is around confidential DeFi. So like I said, AMMs, lending, if you want to try to experiment with flash loans, dart pools, the idea of private DeFi, I would say, is still very much underexplored, so there could be a lot of opportunities here. And lastly, gaming. So yeah, there could be a lot more games that you can build now. Some examples of previous games include fully on-chain Risk. So that's like the bluffing game where it's more strategic than bluffing. So essentially, you have armies across a map, and you can only see your enemies if you're nearby a certain border, right? Or for example, the Mafia game that I explained earlier, that could also be one of the novel type of games. People have built, let's see, Hangman, simple guessing game. So yeah, there's just many new games that you could be building. And yeah, lastly, you do have a chance to be part of our Builders Advocate program. We'll have a booth somewhere in the venue, and then yeah, definitely come talk to us. We're happy to provide you feedback on your idea, and then our team members are also here to help you debug if you have any problems. And so you can find our documentation here. We have a couple demos on this arcade page, and we also have a Discord channel here, and we do have a hackathon channel. So if you need any support from on the technical side, definitely ping us. And yeah, that concludes the workshop. Yeah, any questions? Okay, great. Thank you.
Oh, you've got this, but not the dongle.
What do you mean? Why? You put this in the...
This one. Yeah, yeah, you can do that. Oh, you want to put this one inside here? I see.
Why? It's not necessary.
Yeah, I know, but like I don't want to risk the Wi-Fi cutting out.
Yeah, I know. There you go, and if you do now the screen mirroring,
Allow accessory to connect. Allow.
yes. And then wait a second. And then if you go to settings, yeah.
Why is it not appearing?
Oh.
Display settings.
There we go.
Main display.
Mirror. Yes. And then we wait 2 minutes, and we start at 3:20. Yeah. 1 minute. So I'll make a second.
Yeah. Okay. Doing a bit of last minute stuff myself.
Yeah, 1 minute. And I'll wave to you when you have 1 minute.
Yeah, yeah. Cool, cool. Thanks so much. Testing, testing. This microphone's a bit challenging. It keeps toppling over.
Keep it like this, and then it has a position where it's...
All right, testing, testing. Yeah. All right, I'm gonna have to lean forward. Hang on. One sec. Trying to get the angle of this right. Okay, much better. Testing, testing. Testing. Yeah? All right, hi everyone. Welcome to the Hedera workshop for today. Thank you for joining me today. Now, the first thing I'd like to say is that this is a very long workshop that's 1.5 hours long originally, but we're going to cut it down to just 20 minutes because ETHGlobal has a fast-paced format. If you'd like to watch the full thing, which I just ran yesterday, check out this QR code. I'll leave it up on the screen for a second. It's a YouTube video which includes a talk about Hedera that is just covering the basics, and it's a non-technical talk, effectively, right? Okay, so thank you. A few more of you have joined us. Thank you. Just scan the QR code. You can watch that YouTube video this later on. And sorry, one more. This is a YouTube video. Scan that as well, and you can watch it later on. And I think I'll start now. Okay, so I'll introduce myself. Hi, I'm Brendan. I am a developer relations engineer at Hedera. And Hedera is a layer 1 blockchain that is EVM compatible, but is also a superset of the EVM because it has a couple of other things, a consensus service and a token service. And the token service is something that we'll talk about today as well. So I'm going to jump straight into the demo. Now, if you have followed the link, right, you should end up at Hedera Hackathon resources as a GitHub repo. I'd encourage you to read everything else, but for now, let's just go to Let's Build, and then open up this link, Hedera Tokens CYOA tutorial. And when you go there, you'll come to this tab, GitHub README. And this has been set up such that you can be productive and build something on Hedera within 5 minutes or 10 minutes. Basically everything runs in your browser. All you need is a GitHub account. So open this in a new tab, right? And if you've never used Gitpod before, what it is a Docker account with very good developer experience, right? That's the way I like to describe it. So spin up a Docker instance. That's what it's doing now. And then, let me just make this a bit bigger. Hang on. Don't want to make it that big. All right. So once you've got here, what you'll see is Visual Studio Code, and it is running inside of your browser. So this is not your desktop Visual Studio Code, but everything is as you might expect in terms of the UI. You've got your files on the left, you've got your file editing area in the middle, and you've got a terminal at the bottom. Now, what the terminal is doing is it's saying, I'm going to help you to initialize the .env file, and in the background, it is also going to install all the dependencies and run them for you. So it makes development very easy. So I'll just show you what the .env file looks like at the moment. It's basically empty, right? And you can fill these in manually if you like, but it's far easier to use this script. So enter a BIP39 seed phrase, hit enter, default, generate a new one. Number of accounts, 3, default as well. RPC endpoint, default, all right? It'll set one up for you. And finally, enter your operator account private key. So operator account is the account that you want to run your scripts using. So just hit enter to use the default, which is the first one that you've generated from your seed phrase. And finally, we have this step over here where it's saying, hey, you need to use a faucet to fund your operator account so that you can begin using transactions. So let's copy that address that starts with 0x, your EVM address, and hold down Command and click the URL, faucet.hedera.com, and that'll open up in a new tab. So if you've used a faucet before, the next few steps will be quite familiar to you. So just paste your address here, press the receive button, then press I'm not a robot, just in case you are. Press confirm transaction, and within a couple of seconds, you should see HBAR successfully sent, right? That means that the account that you have generated inside of the script is now funded with 100 HBAR, HBAR being the cryptocurrency on Hedera, and you can use that to do transactions, for example, create tokens, deploy your smart contracts, etc. Right? So once you're back here, just click in the terminal one more time, press enter, and then it'll do some stuff in the background. It's basically saying, hey, I'm going to make a few more accounts, and then I'm going to transfer an amount of HBAR from the first account to the other accounts so that they are also funded. So at the end of it, it says, okay, so here is the proposed .env file. just type Y, enter, and this file updates, right? So, of course, if you're doing this on mainnet, not a good idea to show everyone else, but this is testnet, so it's not a big problem. Okay, so we can close the .env file, and you'll notice over here this little pop-up. What it's just telling you here is that you've run your own instance of an RPC relay. That's your JSON RPC endpoint. It's running here in the background. You don't need to care about it, just FYI, right? Okay, now we're ready. So there are 3 different ways that we can do a token, and I'll try to get through to all 3 of them if possible, but most likely in 20 minutes I can only get to 1 or 2. So here we go, right? So let's start with token HSCS. This is probably the one that most of you are familiar with if you're EVM developers, right? So I'm going to run this script over here. What I'd like to point out is that we're running on Hedera, and I'll make this a little bit smaller, just so it's easier to see. You'll notice that I am not using any additional libraries to interact with Hedera network that you wouldn't with an EVM network. I'm using VM over here. You can use ETHGlobal, Web3.js, whatever you prefer. It'll just work as expected. Now, let's run the script. So cd token HSCS, and then run the script, /script, and autocomplete. Run that. Now, I've set up the scripts such that whenever you see one of these purple lines, what that means is that underneath it, you've got a file URL. You just hold down Command and click on it, and then it'll jump you to the part in the script where that action is about to occur. So it's kind of like a self-tutorial almost. The script teaches you how it uses itself, right? And so what this is doing is it's reading a Solidity file, and it says, okay, I've read the Solidity file. Now this next step is going to fail, right? Because we haven't compiled the Solidity file yet, but let's just see what happens. So you should get an error. Now what we're going to do is run the Solidity compiler. I've set up a script for this. What was it? Compile-smart-contract, and then run that. So that runs sol.cjs. I would like to highlight that this is the same Solidity compiler that you would use on Ethereum or any other EVM network. Nothing special about it. So now you'll see that we have an ABI file, right? JSON interface description of your smart contract, and you've got a bin file, which is your EVM bytecode, right? The same set of bytecode that you would use on any other EVM network. Now, let's rerun the script, right? And this time we're expecting it to succeed. So reading in the Solidity file, reading in the ABI, so that failed previously, now it's running, right? So we've got a bytecode, we've also got our ABI read in. Now it's checking that our RPC relay, which is over here, is running. So let's just do that. So that was successful. Now we'll submit an EVM transaction. So let's take a look at what's going to happen here, right? So this client is an instance of VM, the EVM library, right? EVM client library. And you're calling deploy contract on it and passing in the ABI and the bytecode, these 2 files. And then you're going to pass in constructor arguments, right, for symbol and name. And then we'll submit the transaction to the network. So let's go ahead and run that. And this transaction will take maybe a couple of seconds, and we're expecting a smart contract to be deployed at the end of it. Now, when the smart contract is deployed, it will only contain the bytecode, and you will be able to see it on a block explorer, right? So this thing over here, this URL, hashscan.io/testnet/contract/address, let's command click and open that. And we can see over here that we have the smart contract that has been successfully deployed, and you can see it on the Explorer. Now, what you'll see here is smart contract bytecode. Not very useful. It's not human readable. So other developers who want to interact with your smart contract, you know it's a token, but they may not know it's a token unless they know how to reverse engineer EVM bytecode or something, right? But we have a solution to that, right? So we're going to do verification. So Sourceify is integrated with Hedera on Hashcan, and we're just going to call that. And it says, okay, verification status is perfect because it has used this metadata JSON that is the output of the Solidity compiler. Okay, cool. So what we're going to do instead of next step is we're going to refresh this, and we can see the same smart contract again, right? It's the exact same smart contract, but check it out, right? Previously, we only had bytecode. now we also have the source code, so you can see the full Solidity source code of this particular token, the standard ERC20 token. And then you can also have an API, and you can even interact with the API if you want to via a form, similar to how you do it on EtherScan. All right, so let's go back to Gitpod and go back to the terminal. So what's happening next is we're going to interact with the smart contract, right? So this is an ERC20 smart contract that has been deployed. We're calling write contract via the VM client-side library, saying this is the token smart contract address, and this is an API. I'm identifying the function as transfer, and the parameters are the to address and the amount. So I'm transferring 100 units of this particular token via smart contract call. Let's go ahead and do that. Press enter in the terminal. And this will be, also should take a couple of seconds, but it should be slightly faster than deployment. And there we go. All right, so we can see the transaction if we want to in Hashcan. So you can take a look at that. So we can see that there has been a smart contract transaction. And because it's been verified, we can actually see all of the results over here. Let me just make that a bit bigger. You can see the from and to address. You can see the signature, which was the transfer function, and the input and the output. So everything is as expected. Now let's query the token balance. So now we're doing client.read contract. So we're passing in the token address, the token API. This time we're calling balance of function. Balance of is a view function, so there's no transaction that needs to be sent to the network. And so this should be much faster. Press enter, and you get 100 units as expected, right? Just note that JavaScript numbers go up to 2 to the power 53, whereas uint256 is 2 to the power 56. So therefore, we need to use big numbers, hence the end. That's just JavaScript notation. All right, so how long did we take to do all of that, like including the setup all the way through till completing the first task? Anyone want to guess? 6 minutes? All right, I think you got a timer, have you? There you go. It was 9 minutes and 8 seconds, but this particular task took 5 minutes. So yeah, somewhere in between. So what I wanted to do here is that I'm in DevRel, and one of the things that I like to optimize for is a good developer experience. And a good developer experience is a fast one, fast and error-free, so less frustration. So if you can get from nothing, right, all the way through to completing your first task, in this case, creating a token, deploying a smart contract in less than 10 minutes, hopefully less than 5 in some cases. So if I don't have explanations, maybe under 5, then, to me, that's a good developer experience. But I think it's important that you also know exactly how fast you can be productive on Hedera. So I encourage you to try this out on your own. I'll leave the QR code up later on. And let's see, I might have time for the next demo, so I'm going to be a bit cheeky and do 2. And I might get cut off halfway through. So let's see how it goes. So I mentioned earlier on that there's a smart contract way to do a token, which you are familiar with. That was an ERC20 token. There's also a Hedera native way that uses Hedera token service, right? So these tokens are intrinsically understood at a protocol level. They don't need to go through a virtual machine execution layer. So no EVM is necessarily involved, right? It just, and it's much faster and much more efficient because there is no intermediary, there's no VM. So what you'll notice here is that instead of using the VM library, I am using Hashgraph SDK, right? So this is the Hedera SDK, and it comes in JavaScript, Java, Go, and a few other languages that you might already be familiar with. So I'm going to open this file now. So cd /token-hts. And this time, because we're short of time, I'm just going to run through it really quickly. I'm not going to do as many explanations. So over here, I'm going to create a new token create transaction, and this is it. This is all the code that you need to create a transaction that deploys a token. No smart contract involved. Just one JavaScript function with change methods with the configuration parameters. That's it. I'm not like hiding anything. This is the entirety of token creation, right? Let's press enter. Okay, next one is over here. We're going to sign the transaction, and then we're going to deploy it, send the transaction to the network. All right, and there we go. We have a token, right? No smart contract was involved. There's nothing hiding. It's just all in the SDK. So here we have a fungible token with all the parameters that we've configured, and we have balance in the one account that we have, the operator account. Now, we're going to do something called token association. This is just an additional step. You can't just transfer an HTS token to any random address. It has to allow it to be transferred to it. So that's a bit different from ERC20 tokens, which are, they don't require that whitelist. All right, so we'll submit the token transaction. Okay, so now we've transferred the token as well. And let's check it out, right? So we've got a transfer, and we can see over here, this is transaction fees, essentially, and this one's a token transfer. We've transferred 100 units of the token with 2 decimal places, so, from this account to the other account, and the transaction has been successful. Now, let's take a look at how long that took us, right? So the total time that we took for both put together is just under 13 minutes, and this HTS one actually just took us just over 1 minute. That's how fast it is, right? Cool. I think we might actually have how much longer? Sorry? Oh, amazing. Okay, so one more thing that I can demonstrate. I might go 3 for 3. Okay, cd ... token interop. Right, this one has to be really fast. This is more advanced, right? So I'm just going to go ahead and run this script, right? Now you notice here, what I'm going to be doing is interacting with the HTS token, but without using the Hedera SDK. I'm using VM over here. So I'm using EVM tooling to talk to my HTS token to demonstrate interoperability. Sorry, /scripts, and run that. Right, so reminder, you have to do the previous scripts before. Now, obtain the EVM address, which we have saved before, load the ABI, check the JSON RPC endpoint, and then now we submit an EVM transaction. So now we're using VM, and I'll show you what this looks like, right? We're using write contract from VM, and somehow we're interacting with a Hedera native service, and it actually works, right? Now let's query the token balance, and previously we had at 100, now it has 200, and it's complete. And let's see, that took us half a minute, right? So really fast. Now, how did that work behind the scenes, right? Let's see. This is a bit advanced. This is Hedera improvement proposal, similar to EIP, and you can actually, it does something called a proxy redirect facade. But what that means is that if you're more comfortable with using EVM developer tools and client-side libraries, you can still use HTS, and it works seamlessly. That's effectively what it means. I think I actually finished everything I wanted to demonstrate today, so amazing. Do we have time for questions? Questions? Yes. What kind of, sorry? Indexer. Okay, so the question was what kind of indexer does Hedera use? So it has something called a mirror node, and the mirror node basically takes every transaction and it indexes it. You can think of it as equivalent to an archival node. What's interesting about Hedera is that it doesn't have the main nodes that execute. They only keep state for a few minutes, and then it discards everything else. So the mirror nodes pick up the entire state and keep it. So the consensus is different from complete state. Yeah. So that's effectively your indexer. Now you can also build third-party indexers on top of that, and some do exist. But maybe we can discuss that after this talk. Do we have another question? All good? Amazing. Thank you very much. Okay, how's that? Thank you. So second time doing ETHGlobal. So the first time was such a challenge doing it in 20 minutes.
Only gets better.
I was not expecting to do all three.
yourself.
It's born good. All right, are you ready? Alrighty. How we doing? Are we ready to go? Let's go. So let's talk about V-Layer. Who heard about V-Layer before? Oh, just one person. Excellent. Oh boy. All right, so you're gonna be really excited. Who's a Solidity developer? Who develops? Everyone, almost everyone. Awesome. So guys, V-Layer is bringing 4 new features to Solidity. Not 1, not 2, not 3, well, 4. So time travel, teleport, web proofs, and email proofs, all right? So before we go into the features, let me explain you a new execution model. So if you're familiar with ZK or you know blockchains like Mina or maybe like Alio, that already might look familiar to you. So we have 2 new smart, 1, 2, 3, that's okay? Just checking. Now, but now, can you hear me? They say they can't hear me. I'm getting extra 2 minutes for those sound issues. All right, I can go? Awesome. So, Prover is a smart contract, Solidity smart contract like any other smart contract, but you execute it off-chain. Verifier, on the other hand, is a normal Solidity smart contract that you execute on-chain. And whatever you calculate in Prover, you can take the results and put into Verifier so that you can use those results on-chain. Let me explain. So, yeah, and the important thing about Prover, it has all the superpowers. So, this is a Prover, looks like normal smart contract. It inherits from the base contract called Prover, and you can see it's using setChain ID, and I'm gonna explain in a few slides what it means. But you can think about it as, yeah, that's actually just teleport feature. So we're teleporting to Ethereum to block 122929922, and then we check the balance. The next call, after that, we're gonna check the balance of the NFT. In this case, this is Board Yacht 8 Club NFT, and we can see what the owner, whether this person was the owner of the NFT. But I want to draw your attention to what we're returning here, and what we're returning here is a pair. We return a proof of execution, and we're returning address of the owner. And then we go to Verifier. And Verifier is a smart contract like any other. It inherits from Verifier. And it takes 2 arguments, proof and address. So those are exactly the same arguments that was returned by the prover. And it has this magical modifier only verified, which makes sure that the 2 arguments that it takes are the result of the execution of the prover. And that's pretty much everything you need to know about Prover and Verifier. So now we can go to the superpowers, and we're gonna start with time travel. And already you get a sneak peek of it. So we have this function called setBlock. It has a single parameter, which is the number of the block you wanna time travel to. And the next call after this specific setBlock gonna be executed in the context of the chain as it was at a specific block. Does that make sense to everyone? Easy peasy, right? So here's an example. Let's say I want to prove on-chain that someone is a hodler. I time travel to a very old block. I'm time travel again to another block that is old, but not as old as the first one. I take the balance off at both of those blocks, and I return the minimum, and that is considered the hodl amount. Yeah, the second superpower is a teleport, very similar to time travel, but now I can teleport to another chain. And I do it with a setChain function. SetChain function has 2 parameters, chain ID and block number I want to teleport to. And the following call after setChain gonna be executed in the context of this specific chain of this specific block. So this is even so precise that it runs different hard forks if I teleport to or time travel to a specific hard fork. Right, so here's an example of a method. What it does is I can calculate the balance of an account across multiple chains. Right? So in this case, I'm aggregating the balance from Optimism and Base for a specific account. All right, 2 more to go. So web proofs. And let me start with an example because it's a little less intuitive to think about the web proofs. So web proofs are like private oracles. So you can get a private data onto the Solidity smart contract. And here's an example. Let's say you are a real world asset manager and you want to issue token. Maybe it's a gold token or maybe it's a stable coin. So if I want to issue mint a new token, I first need to prove, go to my bank, and there is a special extension involved. So you go with this extension, you go to your bank, you get your balance on the account, and you hit that generate proof button. And when you do, the proof is generated. You go back to your application, you hold your proof in your hand, and now you can submit an issue token. Does that make sense? Of course, someone can have $1 million on the account, issue a lot of token, and then spend the money. So you probably want to do it periodically, and real-world assets will never gonna be fully permissionless. But with this technology, we can make them much more close to trust minimized solutions versus what we have today, which is, you have to trust the manager of the token that he's honest. And another interesting examples are Web 2, Web 3 markets, where you can use Web 3 code, when you can use smart contracts to trade things in the real world. And one very specific example I'm going to explain is building an on-ramp when you're basically trading tokens for fiat money. And the way you could build it, and there was a team that already innovated on it called ZK P2P. So what you do is you start your transaction, you go to a bank, you actually do the transaction in the bank, you send the money to a specific bank account, and you generate a proof that the money was transferred. And after that, you go back to your DApp, and inside your DApp you can claim your tokens that were stored in the smart contracts. Does that make sense? Easy peasy? Yeah, so here is an example code for the web proofs. So this specific code, what it does, it basically allows you to mint an NFT with your Twitter name. So this is in Solidity. You get the web proof, the content of the page. In this specific context, we would like to go to Twitter account, to the settings, where it stores your handle. And then you can, using special precompiles for JSON, you can get the username from that. And that way you can prove your own specific Twitter account. Boom, as simple as it is. So yeah, so web proofs allows you to do private attestation, or you can think it as a private oracle. There is a JSON precompile for parsing JSON. Some other precompiles might be coming for HTML or whatever else. And there is a web browser extension that you can use to obtain. So you configure the web extension, you tell the web extension what you want to get, and you go through all those steps. And here's how you do it. You simply create a web proof. You put your own logo there in the extension, and then you can just tell, this is the starting page we want to start with. This is what you expect user to do. And then when the user is in the right place, the proof going to be generated automatically. Does that all make sense to you? All right. So let's go to the last superpower. The last superpower is email proofs. So that's very similar to web proofs in a sense that you can take your data from the email and use it on-chain. So here's the first example, wallet email recovery. So let's say you want to recover, you lost your private key and you want to recover your wallet. You probably need to use account abstraction for that, or you need another type of smart wallet. But what you can do, what you can build with that is you can have this website where you go and you say, hey, I want to recover my wallet. This is the address of my wallet. This is the new address. I would like to have control over my wallet. You hit that confirm button. It sends you an email by the wallet recovery service. And this email has specific structure, a much specific template. And all you need to do is reply yes. You reply yes to this email, and everything happens under the hood. In Solidity, you can verify the authenticity of the email, and you can recover this wallet permissionlessly. Yeah, and I'm gonna also go back to real-world asset example to give you a little bit of a comparison. What are the differences and similarities between web proofs and email proofs? So let's say let's say you want to issue a gold token that is a stable token tied to gold, right? So it happens that in many countries you need to have a custodian, and custodian needs to send you updates about what is your state of your custody. So, and most of the time they do it with emails. So this time you're gonna need a plugin for the email. So you go to the admin panel, you go to your inbox, you find around the email, and you need this special button inside your email client. You hit that button, generate the proof, and you know the rest of the game. So how does it look from the code perspective? Well, it's very simple. You just provide unverified email. There is a special method called verify that allows to verify authenticity of the email. It's fairly simple because all the emails are signed by the mail servers. So we just verify if the signature is correct. And yeah, and then off you go. You can start parsing those fields of the email, whether it's from, subject, body, and we give you regular expression precompiled, so you can do it easily inside Solidity. All right, so yeah. It's very easy to install. You just download vLayer app, you install it with vLayer app, and then you can vLayer init ---- template. And we have a template for web proof, email proof, time travel, and teleport. So you don't need to build it from scratch. You can start from the example. You don't need to do the photos. The only photos you need to do is of this address, book.vlayer.xyz. So this is where the documentation is. We have getting started, every single feature explained in detail, including all the parsing stuff for JSON and regular expressions, all the different nuances you need to know. And I wanna just draw your attention to chapter 4, which has all the information about how to use it from JavaScript, how to run proving, how to run browser extension, and all that stuff. Yeah, and verified data is not our new original idea. You might have seen some verified data like ZK TLS, ZK email, or coprocessors. So I want to mention all the things I ain't gonna be talking about today. So this is all the things you don't need to know and care about when you're using vLayer. So you don't need to know cryptography. You don't need to know what our prime fields and elliptic curves are. You don't need to learn new languages and what circuits are, what guest IDs are, and all that stuff. You don't need to know what DKAM records are. You don't need to know what the storage proofs are and Malcolm mountain ranges. You don't even need to really deeply understand how the Ethereum works. In a sense, you know, what are the headers, what are the slots calculation. Maybe some of you were on one of those presentations when people doing cross-chain stuff, and you know, there's a 10 minutes presentation explaining how it works, and then another 30 just on the slot calculation. So you don't need even to know how to do ABI. Whatever prover is returning, you're just flashing to the verifier, and it's done. That's all the ZK knowledge you need to know. And you don't need to know you don't need to study fancy architecture diagrams. So if you've been in the space for a while and you might stumble upon one of those diagrams, each of this diagram is taken from the beginner section or installation sections or how it works sections. This is not advanced diagrams in the architecture chapters. So this is our architecture diagram for comparison. And how we're doing with time, we still have 5 minutes, so we're talking about the most important thing of the day, which is the bounties. We have 10,000 in bounties. 4,000, this is new technology, a lot of new possibilities. People are discussing what you can build with that, but we think we're only scratching the surface, and there's gonna be so much more to build that we didn't even think about. So the biggest bounty, $4,000, is for most inspiring use of vLayer superpowers. And there is also 2,000 for the best use of web proofs, 2,000 for the best use of email proofs, and 2,000 for the best use either time travel or teleport. Alrighty, and we have merge bounties. So Polygon is one. So there is super exciting stuff that Polygon is doing, and we're super excited about all the different ideas how it can be used on Polygon. So take a look at that. We love Polygon, guys. Hope they love us. And yeah, so here are some ideas. Here is more ideas how you can use vLayer with a Polygon and how you can grab those merge bounties. And we also have merge bounties with Circle. We love Circle. You can see in our examples, we use USDC all the time. So there is 2 bounties we think they're gonna be especially interesting for doing merge bounties with vLayer. Yeah, thank you. And we're ahead of time, 3 minutes. Maybe there are questions. There is one question. Yeah, let's talk about web proofs. I'm gonna repeat the question, sir. No worries. So the web proofs. Let me go. Yeah. So there are significant limitations and things you need to be aware when you build. It's all in the documentation, but I'm gonna mention it specifically. So first of all, your web proof, you want it to be small. 1 kilobyte is great. 10 kilobyte is fine. Everything over few dozens of kilobytes is probably too big because there is a huge overhead. There is a multi-party computation algorithm happening under the hood, and it has 1,000 overhead. So it means for every kilobyte you want to prove, you need to send 1 megabyte of data over the network. This is getting better. Early next year, we should be having 100 times overhead, so 10 times faster. But it's never going to be super fast because it's advanced cryptography, and it's going to take time to optimize, and it's never going to be, one time. So that's one thing to know about. Second thing to know about, we provide JSON precompiled for parsing JSON. So in theory, you can parse HTML, you can parse XML, whatever else. It's just the JSON is that we support initially as the most popular and important format to use. So you probably want to use for those JSON-related things, or for those pull requests. Not pull requests, but those JSON, those AJAX calls that returns data in JSON. So most oftentimes when you have single-page applications, that's where you get this data fairly easily, right? Under the hood, there are some pull requests. And one thing to remember, there is a lot of confusion, I think, about web proofs. You can think about it as a private oracle. So when you have an oracle, it allows you to get data from the public sources. The big innovation of the web proofs is you can take this data from your bank account without risking your private data, right? So for example, there is a special way to redact security sensitive data like session keys, right? So this is the power of the web proofs. You still need to trust, like you need to trust Oracle, you need to trust a notary, which is basically a private oracle. So that's something to keep in mind. Of course, you can run a network of notaries, and we are building, people are building, we are building that. So that's gonna happen, but yeah, this is the security trust assumptions that's important to remember about. One last very quick question. Very fast question. I have a question. You wanna get some of those sweet bounties from VLayer? Yes, woo! Thank you very much, guys. See you on the judging.
And then you have to do the mirroring in the settings of the display.
How to do it?
And you
I
got
think
this.
it's not working. Wait,
Oh, yeah. And then you have to open settings.
settings. Wow. Hello. Hello, hello. Yeah, just. Wait, hello, hello. Can you hear me? I think yeah. Now there is sound. Hello, guys. Nice to meet you. Uh, Welcome to Scroll's workshop. I'm Vincent from Scroll DevRel team, and today's topic gonna cover L1 load, which is a super powerful precompile that allows to direct read L1 data from your L2 contract, and you can integrate this powerful feature into L2 apps and make some very creative features, playful features in your project. And today's we will split our content into 4 different parts. I will go through first 2 really quick because we have limited time of 30 minutes. And I want to reserve as many time as in our demo part. I will show you some code example about how you use L1 load. So first, let's discuss the idea behind L1 load. It is called L1 load, so you have to have some basic knowledge about L1 and L2. I will go this very quick because I guess you are the professional hackers. You know some basic information about it. So in order to solve a blockchain trilemma, which we are known, it is almost very high security, very high decentralized level, and super scalable for every blockchain. Especially we know Bitcoin and Ethereum has facing those problems. They are very secure, they are very decentralized, but they ability. So in order to solve this, we have built up layer 2, so-called rollups. There's 2 achievements to build up rollups. One is using fraud proofs, also known as optimistic rollups. Another one is using ZK proof, which means it's using mathematical equation to guarantee that your input is definitely correct. So Scroll is a ZK EVM layer 2 based on Ethereum ecosystem, so we can characterize Scroll as ZK rollups instead of the optimistic rollups. They're using fraud proof and have longer exit window because they have to pass the challenge time. Usually it takes 7 days. But when you use ZK proof, it can be verified very fast. Like Scroll has a very fast finality time. For example, if you withdraw your assets from Scroll to Ethereum layer 1, for now it's only take you less than 40 minutes. And I think it's the fastest among all of the ZK rollups for now. And this is the typical structures which the ZK rollup looks like. You have a sequencer. It's a duty for sequencers to produce blocks, arrange the transactions order, and then you before you submit back to layer 1 to do some verification, you will have your prover to generate ZK proofs for your blocks, and there's a special aggregator which can aggregate many blocks together so that you only submit once, but you can prove many blocks. For example, for now, Scroll, maybe one bundle of Scroll ZK proof can prove over 10 blocks for now. And you will pass your ZK proof to a smart contract as a verifier, which deploy on Ethereum. If it passed, it can mathematically prove that all of your transactions within the blocks are correct. So people's transactions are correct, then you can release your assets from layer 2 to layer 1. It's a very fast process. But there's still many reasons to use L1's data directly from L2. Why? Because there's few advantages. First, it's the data stored on layer 1, especially on the Ethereum, is super secure, and it's also decentralized guarantees. And also, the data on the layer 1 is also acceptable for all of the other blockchains or layer 2s. So once you accessing data on layer 1, you can also reflecting your changes on different layer 2 which can access the data. So that's why we come up with this idea of L1 load precompile. Because there's so many layer 2s right now. If you're a user want to manage account states, the most efficient way, I think, is they both reading the data from layer 1 instead of on different layer 2, and they have to communicate with each other. Let's give you only need to make your change once. All the other layer 2 can reflect in the changes and make some very fun functionality. For example, if I holding a special token on layer 1, and if I gain more tokens on different layer 2, if they can read my balance on layer 1, and they can do a corresponding action. For example, if I accumulate my token over 1,000, I can get some free NFT mint. But if you read data from another layer 2, it is quite hard for people to maintain their own states on different layer 2. So we finish this part and we'll introduce you about what is L1S load. So L1S load is a precompile that I just explained before. We want to enable user to directly read L1 data through a integrate with L1 L2D apps. It is currently now our RIP instead of our EIP is still in proposal stage, but it's proposed by one of our co-founder and our CTO Hai Chen. You can check the details of this proposal under RIP 7728. And if you think it's very useful, you can vote for it. And we hope we can pass this to become a real EIP in a very short amount of time. This is basically idea. For example, we have some key information stored on layer 1, which is so-called Ethereum. And we have two different layer 2 can both access that layer 1. So for example, if I store my key A on layer 1 and both scroll and OP can read that key. And if I replace my key A to key B, we do the scroll and OP network can automatically reflecting this change without asking again. Because now they're accessing key B now. Let's go through some implementation details about L1S load. You don't need to worry about too much. I just want to emphasize the actual implementation, which is under this part. It's explain you how L1S load actually works. So when the L2 node encounters a call of the L1S load precompile, it will go verify if the input is well-formed. If this well-formed, it go actually to call Ethereum or layer 1 block RPC query to this one. Is get storage at address. So basically it will fetch the data from the L1 node, and then it will give you output buffer to your to which the smart contract or user called L1S load precompile. We want to also examine the how the input and how the output looks like and how the gas fee you cost. Basically, right now the standard is it have the fixed gas cost 2,000. For each of the extra slots that you want to read, you will adding more 2,000 to your call. And right now the maximum call slots per time is 5. It does not mean from 0 to 5 slots. You can choose whichever slot that you like. But the maximum number of slots you can retrieve one time is 5. And the output or the return types, it looks like this. It will divide it by slot and ordered one by one with your order of keys. And each of the return slots data contains 32 bytes of data. And this is a very simple usage. You try to integrate your L1S load into your smart contract. You can just basically first you need to load the address of L1S load because it's a precompile. The contract address is fixed. I will give you the contract address later. But when you want to use it, you just call the address static call, encode with your layer 1 contract address and your key. Keys also means slot number. If you know your slot number, you can access whatever data that you stored on layer 1. I will give you a code example during our demo time. And before you actually can use it, you need to get some testnet token because L1S load is not available on Scroll Sepolia. Currently, we have created a separate testnet for it. It's called Scroll L1S load devnet, and we have special faucet for it. It is Telegram bot. If you want to gain some token, you can scan this QR code and get access to this bot Telegram group. It's very easy. You just simply type /job with your destinate address, then you can receive 0.1 testnet token on it. And we also create many useful reference and guides for using L1S load. This is a very typical one, and I think it's very useful. You can scan a QR code I provide to you, and this is all the network setting that you needed to connect with Scroll DevNet, which L1S load is available. I will pause there for a few seconds for you to scan the code. And I think everything's ready. Now we can start our journey with L1S load. this is a Telegram group, Faucet Telegram group that I just mentioned. Here is just some use case. You job with your account address, and then you can get 0.1 test token for free. And I will leave it here, probably drag it back to my main window, and I will drag my code example here. Well, it's to operating in different window. It's really challengeable, but I hope I'm doing it. Okay, cool. So I'm using Remix. It's a well-known web coding explorer, and it's very easy for everyone to use it and debugging your smart contract. I have provided 2 smart contracts for you. One is called Let's Scroll token contract, which I'm gonna put this contract on the layer 1. In this case, it will be on Ethereum's testnet, Sepolia. And then I will use my L2 consumer contract to retrieve our storage data on the Let's Scroll token. What am I gonna do? I'm gonna try to retrieve the balance of it and retrieve the name and the token symbol on it, and then to give idea about how L1 S-Load looks like. Let's first examine this token contract in details. So this L1 token, it's ERC20. I have using a library from OpenZeppelin ERC20. I will explain to you why I want to use it, because I want you to be aware of some small things, because if you forget to understand the slot arrangement, then you may encounter into some trouble when you're trying to load your slot. And then I provide few variables here. We're trying to retrieve them later, okay? But let's see what this contract looks like. It's very simple. When you deploy it, it will mint 1 million of LTS token to the message sender account, which are gonna be my account. And let's examine L2 consumer also. It is an actual code example to using L1 S-Load. So for let's skip this blocks L1 blocks address first, because this is another precompile. We're probably gonna cover it in the different workshop or online video. You can find another details about it. It's also a powerful precompile. It provides you L1 block states on layer 2. But we will focus on layer 2 S-Load, L1 S-Load precompile for now. This is the address of the L1 S-Load precompile deployed on Scroll DevNet. Like I said, it is fixed number, so you can just import it. And this is a customized bytes32 to string function. You can borrow the code directly. And this code example is also live in our guides. So if you go back to scan our QR code, you will find this code base. You can just copy paste if you want to read some, if you want to convert your bytes32 to strings. I will not cover these details because this code example, you can easily generate it from ChatGPT if you like to use. Now here is the important part, retrieve all. This is a function that I write by myself. It takes the L1 contract address, also take my account address as input. It will return 5 things. Remember, when you call L1 S-Load, it's maximum give you 5 slots per call. So I want to retrieve all five data from my L1 account, and I need to I need to calculate the slot number first. In fact, it is very simple because the slot number actually is arranged by orders. So it's starting from 0 to 1, 2, 3, 4 because I have 5 different variables I want to retrieve. Instead of 0, why I put this as account balance stops? Because if you recall the ERC20, let's go back to our Let's Scroll token. That's why I use ERC20, because I want you to be aware our slot 1 is not this owner. It's actually the variables in this smart contract ERC20, because we import OpenZeppelin ERC20 into our account into our smart contract. So actually the slot 0 is this one. The slot 1 is this one. The slot 2 is this one. The slot 3 is this one. The slot 4 is this one, instead of our owner and receiver. You will see it later. And also, for slot 0, it's a mapping structure. It's mapping the address to some number. So it's not 0, because when Solidity compiler compile your mapping structure, it will using a very specific algorithm to contain the actual slots, which I provided here. First of all, you have your base slot is 0, like I explained. This mapping is placed on the slot 0, and then you have to finding out the actual slot number mapping with your account address. So we'll first do check with your account address with slot number, which is 0. You do this quick hash function, and then you get your really account balance slots. So it's whatever it is. So I put it on a 0, and then we have 1, 2, 3, 4. It's just follow the orders, and you can get all of the data. And then when you get back the data, remember the data is raw data. You need to do some you need to do some conversion. I was using the assembly code to do the conversion because the first 3 are the unit 250 u integer 256. So basically, you don't need to do a extra conversion. You just read it. But for the last 2, it's token name and token symbol. It's string. So it is time when we bring back our byte32 to string function. You remember that conversion function that I explained at the very beginning? I want to transfer, convert my byte32 to string. So I use it, and then I get the data back. Okay. And this is for later. This is just retrieve 1. It's only retrieve 1 slot number. Whatever the slot number you put, it gives you the result. I will use this for another example. So let's first try to retrieve all and see what is going to happen. So I have deployed the Let's Scroll token on the Sepolia, I guess, 20 minutes ago. This is the contract address. Yeah, it's like 12 minutes ago. I would like to copy the address first, and then go back to Remix. I want to deploy my L2 consumer, and then so that I can retrieve data on layer 1. So let's do compile layer 2 consumer. Cool. And then I go to deployment. Be sure that you are on the correct network. Currently, it's on Sepolia because the network IT isn't a Scroll DevNet. When you successfully setting up your network, you will be able to switching it through your MetaMask. I will try to find. Yeah, I call my customer network Scroll DevNet. You can also call it L1 SLO. It doesn't matter. Let's check the chain ID again. Now it's correct. So I will deploy it. To deploy it, because I made my L2 consumer ownable, it's not mandatory. It's just my preference because I do not want to clear deploy accidentally. So whenever I want to click deploy, it requires me to put my owner as an input. So I will put myself as owner, and I click deploy, and I will click confirm. Now we have deployed our L2 consumer, and let's use it to retrieve data on layer 1. That's one thing I really like Remix because after you deploy, it provides you the real smart contract interface to you that you can directly interact with. So now let's go to retrieve. Let's do retrieve all to check if the data is correct. So just wanting you to recall what we have done before. So we deploy our layer 1, our Let's Scroll token. It will have 1 million LTS to the minter, okay, to a contract creator. So go back to our layer 1 contract address and put it as an input. And because myself is only owner of this token, so I will put myself as account to it. I will copy my account address and put into this input. I'll just call it. And now you can see the output. I'm not so sure if you can see it clearly. Maybe I zoom it up, zoom in a little bit. Now, so first, just recall to ERC20s like those variable. First is the balance of your account. The second is allowance because currently I do not give any allowance piece outside, so it's 0. And second is the third is total supply of your token. It's 1 million because it has 18 digits, so it looks so long. And then we successfully retrieve the token symbol, let's scroll, and the token name, let's scroll, and token symbol LTS. This is so powerful because it shows you, because currently I'm on Scroll DevNet. You see the chain ID? It's not on Sepolia, but actually I retrieve data from Sepolia. This token is deployed on Sepolia. So that's the user case. Now I want to do some fun things. I want to switch back to Sepolia and then transfer 1,000 LTS to another address. And let's see if the balance of this can be actually changed. First, I want to import that tokens. Yeah, let's go back to our smart contract. I copy the address, and I import the token. Now you see it's LTS, right? And has 18 digits. Let's see how many I have. Looks like currently I have 1 million. Yes, it's 1 million LTS that I have hold. Now I want to transfer this to the others. I will just send. I randomly choose the account. Maybe I will send 1,000. Let's click the continue. Submit. Wait until it's finished. At the meantime, I want to go back to, yeah, it's finished. I want to switch my network back to Scroll DevNet. So now I'm on the different network. Let's see if I can retrieve the changes, if the change is successfully reflecting on layer 2 by using our layer 1 S-load contract. But first, because I switched my network, my previous interface has gone. I need to get it back, but it's very easy. If you click add address with your previous deployed smart contract, you can retrieve it back. So because our Scroll DevNet does not support Etherscan, so you have to use our own block scout built by it. Okay, that is also provided in our L1 S-load guide. You can find everything you need under this guide, including the block explorer. I have shared this QR code before, so it should be easy to find it. Let's see. This is one of our. This is my account address, and let's check this contract creation. This one should be the one that I just created for reading L1 consumer. Just in case, I want to refresh it to get the latest one. Okay. Click the transaction. Let's find the contract address. I think this one is the one that we need. So let's retrieve this interface back again. Let's see if it's, let's check the owner. I'm just assuming this is the correct one because my eyes cannot read it clearly. But let's try retrieve it. Let's see if it works. Looks like this is not our contract address. Let me Oh yeah, because this is not at our scroll devnet. Just be sure this is a common mistake that people would have. You forget change your network. So let's go back to the actual network. Now it's back to scroll devnet instead of Sepolia. Now let's retrieve this again. Now you can see the owner is myself, so I think this one is correct. And let's retrieve all. See the balance of it is actually changed. It's not 1 million again. You can read it. So that's how powerful the L1 S load is. And based on that, you can do a lot of very cool features. You see, for example, if you're holding that amount of token on layer 1, then you can have a free mint of NFT. So you can, based on that, you can do a lot of creativity things. And I want to really quickly go back to my slides and give you some information about our bounty. So yeah, let's give all of things out because our time runs out. So in ETHGlobal, we have provided 2 bounties related to L1 S load. First is best innovation on scroll. It provides maximum 10K USD as an entire prize pool. If you have deployed your smart contract which integrate with L1 S load and deploy on scroll devnet, you will have a chance to win that bounty. And another one, we have a specific track only for L1 S load. It's a best use case for L1 S load. It's no matter what type of the app you have integrated with L1 S load, just deploy and try to show us the evidence that you actually integrate with L1 S load and reading some L1 data through it, then you are also have a chance to win it. And you can, if you do that, you can both apply for these 2 tracks to increase the chance that you win prize. Okay, and I will like, because the time is up, so I need to end up this. Thank you very much. Document? Yes, you can.
Hey everyone, this is Kennel. I am a dev support engineer at Polygon Labs, and today this workshop is regarding how you can bridge your any ERC20 assets across chains connected to Ag layer using Unified Bridge. Um, yeah, bridge any ERC20 assets using Unified Bridge. And this is the whole architecture for that. Like before diving deep into this architecture, I would just like to explain how exactly it will work on a high level overview. So as soon as you, so it's the whole architecture where the Unified Bridge contract plays an important role, and Unified Bridge contract is deployed on L1 as well as all the L2s that are connected to Ag layer. And you can use those Unified Bridge contracts on all these L2s while bridging assets. So it's a copy of instance of all these L2s, of these contracts on L2s. So yeah, that's the whole architecture, and yeah, let's dive deep into it. Yeah, this is the whole flow on how will your transaction go through from each and every Merkle leaf nodes as well as Merkle tree roots. So let's say as soon as you bridge your assets, it will basically, add a leaf to the local exit root tree. It's just a basic Merkle tree with 2 raised to 32 Merkle leaf nodes. And as soon as you bridge your asset, it will so bridge asset will contain all the information regarding your destination chain, your destination address, your token amount, token address, etc. So this information will actually be added into this Merkle leaf node, and it will basically hash the Merkle leaf nodes, two of the Merkle leaf nodes, and it will create a hash for that. And essentially, it will create a local exit root tree on the L2. So basically, it's just a hashing of leaf nodes on every local exit root tree of rollups. And at the end, it will update the global exit root tree node, which is on the L1. And this is how exactly you will verify that my asset is being bridged from L2s to other L2s or just from L1 to L2. So yeah, so as soon as you bridge your asset, it will add as a left node, and it will add it to the Merkle tree to the local of the local exit root tree, and it will update the local exit root as soon as a new bridge asset leaf node has been added. And next, this local exit root tree, not the tree, but this local exit root, it lies on the L2 or any layer 2 chains connected to Ag layer. So it just lies on the L2. But as of now, your L1 or your destination L2 doesn't know like what is exactly happening. So basically, you actually need to update the second root, that is rollup exit root. What is rollup exit root exactly? So basically, you have 5 layer 2s, for example, and there is a single rollup exit root for all these 5 layer L2s. And as soon as, so it's something like as soon as you add leaf nodes to multiple local exit tree roots, it will update multiple local exit tree roots, right? But there is only one root which is called rollup exit root, and it will update that rollup exit root to get synced with all the data and to basically be updated of this current state of the blockchain. So it will just update the rollup exit root. It is on the Polygon rollup manager.sol contract, which lies on L1, that is mainnet. And this again is just a rollup exit root. So it contains, you can say essentially that it contains the state proof or Merkle proof of all the L2s, but not, we are still yet to have the mainnet exit root here, which essentially contains all the information of all the rollups as well as L1. So, and here you actually get the data of my bridge asset, which is added on the layer 2. So yeah, here we come. So as soon as we add this rollup exit root, as soon as it updates the rollup exit root, and eventually it also updates the global exit root. Now what is global exit root? Global exit root is a root node of, for example, if you take a small example, global exit root is a root node of 2 lifts, that is rollup exit root and mainnet exit root. And mainnet exit root is basically root of all the bridge message or bridge asset leaf nodes of the mainnet or of the L1. And this rollup exit root is basically root of all the leaf nodes of all the local exit roots of all the rollups. It's pretty confusing, but all you need to know is like it's just putting a Merkle proof on the L1 so that any L2 can read it and actually claim the asset on the destination chain. Like it's just a proof, a Merkle proof that says that, hey, this asset was bridged on the source chain. Now it's ready to claim. Please claim on the destination chain. So it essentially just says that. So yeah, this is the whole architecture. I would not deep dive into it, but you just need to keep in mind that global exit route is the route that you need to get to claim the asset on the destination chain, because we are waiting for the L1 finality here. So yeah. Here are the code examples. I just go over through one code. I'm not sure if it will work because my PC is giving some issues. My laptop is giving some issues. So I just try it out by cloning my repository here. Yeah, this is a small example where you bridge. We will create a token, ERC20 token named egg, and we will deploy that token contract on Sepolia, and then we will mint that token to our address. We'll approve that token to this unified bridge contract address, and then we will try to bridge it from Sepolia to Polygon zkVM Cardona. So yeah, here we go. I hope that is visible. Okay, I will be needing a couple of things. I think this might take time, and I think we are short on time. Let's try if we can. Probably let's just try to understand the code as of now, because to gather some API keys for Sepolia as well as for Polygon zkVM, it might take some time. And yeah, so let's go ahead and just first understand the code. I don't think we have much time. I think we have 30 minutes. I think we can do that. Let's go. Let's go ahead and grab some API keys to connect to our Sepolia as well as Polygon zkVM Cardona network. Let's go ahead and grab some endpoints. As of now, yeah, I'll just copy this URL and paste it here. I'll rename this file to .env. And I'll just grab this API key and also paste it over here, since we are using Polygon zkVM API of Alchemy. Yeah. I think we are good to go. Let's go ahead and see if we have some funds on, yeah, I think this should be enough. So let's go ahead and deploy our egg token contract. This is a simple contract, as you can see here. It's just an egg token contract with a mint functionality. So it's a simple contract. Let's just deploy it. Deploy. Yeah, and CJS. Yeah. What it will do is it will just deploy this contract on Sepolia network. So as you, I actually need to define the network first because we have a couple of networks in the hardhat config. We have Sepolia, we have Cardano as well as A-star. So I think, okay, it will throw us some error, but yeah, we can run the command again. So essentially it will just deploy this contract to Sepolia network. Oh, strange. It deployed. I think it deployed on a local hardhat chain. So let's go ahead and deploy it on Sepolia network. Yeah. And then we will try to, yeah, here we are. So I'll just copy this contract address, which is of egg token contract. And in the Bridget file, I have a couple of things. I'll just try to explain it. Yeah, this is a token address that we need to bridge from source chain, that is Sepolia, to Polygon zkVM Cardano. So I just paste this token address here. This is a destination address. A destination address could be anything, any EVM address. And yeah, so basically, we have an array. So we need an ID to indicate what is the destination chain as well as what is the source chain. But in this case, in our case, it is not the chain ID, but it is a separate network ID that we have created. So for Sepolia, it's 0. For A-star zkVM, sorry, for Polygon zkVM, it's 1. And for A-star, it's 2. So yeah, just to indicate this network IDs. And yeah, so here is a source network array. I have just created an array to, to bridge asset on the source chain, as well as to claim asset on the destination chain. You need a provider for both of them to interact with the contract of bridge asset, so of the unified bridge. We need a provider for both of them. So I have just defined it here. We are getting private key from ENV. We are getting unified bridge contract ending in 522. It's constant on every single chain. Let it be Sepolia or Polygon zkVM. It's constant on all these chains now. And yeah. So source network ID is basically 0. For our case, we just deployed the contract on Sepolia, so it's 0. And we'll be bridging this asset to the destination network with having ID 1, that is Polygon zkVM Cardano. So basically, yeah, this is destination network ID, destination network address, token contract address, token amount that we want to bridge. And yeah, I think that's it. Now, what we do is we just create a provider, we just create a wallet, essentially to sign the transaction, and then we create a bridge contract instance. That is unified bridge contract instance. We provide unified bridge contract address, unified bridge ABI, as well as the wallet to sign the unified bridge contract address. Transaction. And here we have ERC20 token contract instance. That is to be able to mint those tokens first. We'll just first mint those tokens to our address, and we will approve those tokens to this contract, and then we'll try to bridge these assets. So I just created this ERC20 token contract asset, instance. I'll just probably write here the token address. And yes, I think that should work. And again, I'll just remove this. And I'll write token address here as well. Yeah, I'll just remove this as well and write token amount, the amount of token that we want to mint. Same goes for here. Token amount. Here I just remove this and I'll replace it with unified bridge contract address. Yes. So essentially what we are doing here is we are first minting those tokens to our address. That is the my bad. This should not be token address, but this should be our address. So I'll just copy my address and paste it here in the string format. Yeah. So first we're minting those tokens, the ETH tokens, along with the token amount to this address, that is my address. And the token amount is basically, so it's 18 decimal token. So since we need to mint one token, let's put 18 zeros here first. I'm not sure how many it was. Yeah, now we have 18 decimals here. And I think we are good to go. Yes, token approved, bridge contract, and yes. So let's first try to, so this running the script will essentially mint those tokens to this address and with the token amount as 1. And it will also approve the unified bridge contract to spend those tokens on our behalf. So yeah, let's go ahead and try to see if this works. I think it did. I think so. Let me just. I forgot to wait for this transaction to actually go through because minting and approving takes some time. So I will just wait for this transaction. Await mint dot. I'll just wait for one block as of now. And await approve transaction dot wait. Let's wait for 2 blocks to be sure that the transaction actually went through and is actually included in the block. And yeah, that's pretty much it. I'll go over through this code later on once we actually bridge this transaction. Once we actually mint this token to our address. Let's see if it goes through. Yeah, it will just console log out the whole object of the transaction, and we will just pick out this transaction and see on the Sepolia chain that it actually went through. Yeah, by the time destination network IDs again. So here, this bridge contract instance contains a bridge asset function which actually carries out the bridge transaction, and there are 6 things that you need to pass in. That is destination network ID, destination address, token amount, token address, and force update global exit route. So what this force update global exit route does is, if you put it as true, it will immediately update the global exit route on the L1. So otherwise, it will do it periodically. So if you want to force update it, you can do that too, but it will actually take some more gas fees, but not that much. But yeah. So it will update the force global exit route on the L1 so that you don't have to wait for this for periodically. So there is a bridge service API which is periodically updating this force global exit route on the L1, and the L2 is reading this data and actually sees if the if the transaction is ready to be claimed. So yeah, you can do that by just putting the flag as true. Yeah, as you can see, yeah, tokens just bridge transaction just went through. I just copy this address and see on portal.polygon.technology. I'll just connect my wallet and yeah, I'll switch to the testnet to Sepolia. And when I go to transactions, yeah, here we are. So yeah, transaction was bridged from Sepolia to Cardona. It takes 30 minutes to land into Cardona testnet. So yeah, and you can see, we just bridged for 1 ETH token, and yeah, yeah, it's done. And for Cardona zkVM, you don't need to claim the assets because we are running an auto claiming service in the you can say as backend. But let's say if you are doing otherwise, like if you are bridging asset from Cardona to Sepolia, you need to run this claim asset function by yourself. It's also in the code itself. So what it does is a high level overview is it just fetches all the Merkle proofs that we just talked about in the first part. It fetches the Merkle proof and verifies if these assets are ready to be claimed, and then it claims the asset once we call the claim asset function on the destination contract. That is, again, the bridge contract on the destination chain. Yeah, that's it. Thank you so much.
Hello everyone, welcome to the Gnosis Developer Workshop. Today we are going to be talking about 3 different tracks of 3 different products under the Gnosis Labs. Welcome to ETHGlobal Bangkok, the biggest hackathon of this year so far. A lot of bounties and a lot of excitement, and we have also brought some interesting bounties, and we are going to be talking about those in a while. So all of you have probably, most of you have heard about Gnosis already, maybe from the prediction market era or from the Gnosis chain perspective. But today we are going to be talking about the Gnosis 3.0 vision, which is much more focused on payments and open financial infrastructure. So as I mentioned, like there will be 3 different products, 3 different kind of bounties, and you can build a lot of iterations in amongst those. So the first one is cross-chain application using Hashi. This is what I will be covering. And the second one is payment-focused applications using Gnosis Pay. It's a Visa card using which you can customize your application based upon the usage. And then the third one is the social and community-focused apps using Circles SDK. And Vanshika later will be covering in depth about it. So let's cover Hashi. So Hashi is a robust EVM hash Oracle aggregator. What it is, like I'm going to be talking about it on how it works a little bit in the next slide. But what you can take away from this one statement is that it gives you the ability to verify something on other chain from one except like other chain. So for example, if you are on Polygon, you can verify something of the state of if something has happened, any kind of occurrence on the other chain. It's designed to enhance the security of cross-chain applications. So it's not exactly a bridge application. Like technically you would use Hashi on top of a bridge to increase its adaptability. And it reaches consensus between multiple oracles. So this is one of the features of Hashi in which it's not dependent on just one oracle. You can plug in and play with a number of oracles. And we're going to be talking about which those oracles are. So as I mentioned, Hashi relays full block headers, and most of you already know that just with the block header, you can derive the entire state transaction root history. So from that, you can verify what has happened in that particular block, or even any of the previous blocks ever happened to that particular chain. And dApps can thus verify full state of the original chain. So if you want to see any kind of transaction changes or the state changes in any of the past chain, like blocks, you can verify that through Hashi. You can build cryptographic proofs based on the actual blockchain state. Now, the flexibility of the framework comes with the number of features. So supports a lot of chains. We are going to be talking about which chains. A lot of oracles. You can use multiple oracles at the same time to increase your adaptability. So even if one goes down, or if you think that only using one oracle may or may not be secure enough, you can use multiple of those. Supports arbitrary message passing, which is also useful for cross-chain applications, and provides an abstraction layer for oracles. You can integrate Oracle with a simple adapter. So for example, if you want to integrate 3 different oracles, you just need to put up the adapter hash in your while configuring the smart contract, and you're done. Like you have now support for 3 different oracles. And these are the chains and the oracles. So you can see Gnosis and the Shadow testnet, Ethereum, Sepolia, Polygon, Arbitrum Base, Unichain. You can find all of those details and the adapters hashes which you will need for your application in the docs. And also on the Oracle side, we have like all the bigger ones, Layer 0, CCIP, Hyperbridge, Wormhole, and some ZK oracles. So basically, anything, if you are building cross-chain dApp, or if you want to verify a state from one part or to the other, like from one chain to the other, you can use Hashi for that. And that's pretty much it. Like we will be there at the booth, so definitely come and share any kind of questions you have. And with that, I will pass on the mic to Vanshika to cover circles and Gnosis Pay.
Hey everyone, thank you so much for joining the workshop. I'm Vanshika, I'm the another developer relations at Gnosis. And I would be talking about circles and Gnosis Pay today. I know a lot of people have heard about the word circle in general, but it's a very different protocol that we are building with Gnosis chain itself. So in the shortest and the simplest way to explain what circles is, it's a sort of a decentralized web of trust, and it enables like fair issuance of personal money. I know the terms might sound a bit tricky, but the idea of circles in general is that you are supposed to connect with people on real-time basis. And there's also a soft Sybil resistance involved here because you can send your personal circles token to the people who actually trust you. So consider this as a situation that we are in ETHGlobal Bangkok and we want to connect with all the people and accept some set of tokens, token of appreciation, but it would only happen when there is a form of trust between all of us. So this is what circles sort of enables you to do that. Now, who can create the circles account and issue the money? Well, it is technically everyone. You can simply create an account, and in order for you to join the network, you would just need to be invited, right? So it's sort of a decision of the people who are part of the network. Let's say if I know you, I have known you for a long time, or I've just met you in hackathon, and I know you are a real person, I can simply invite you to the network and enable you to be participate in the entire trust network, also connect with other people that are part of it. So there are 3 core rules of circles, like in the SDK, how would it be working? So first one is, of course, the issuance rate. So circles are issued to you every single hour. So that means 1 circles token every single hour, and that is 24 circles in a whole day. So there is no way possible for you to create more circles in any way, which is why we also say that if there was a bot, it cannot generate more than 24 circles token every single day. So if you want to utilize it from also like a soft Sybil resistance, please feel free to do so. The second point is, of course, 7% demurrage. So as we all know that deflation is a very important concept of money in general, we also wanted to implement that in Circles protocol. So you can basically, all the circle balances are basically have CRC, 7% demurrage to the CRC tokens. So on the real-time basis, you would always see that there is a 7% annual demurrage of your circle balances, all token balances. Now, there is also a selective trust system. So that means that users have control over to whom they are actually sending the CRC tokens and to whom they are basically accepting from. So if A trusts B, then this indicates that A is willing to exchange the B CRC tokens for the same ratio. So just to simplify that, this is like a transitive flow between these 2 people. For example, I want to send, let's say, some 100 CRC tokens to this person C, and there's a trust connection between A and B. So how would I send these tokens to this person C right here? So I would first of all deduct 100 CRC tokens from this person, send it over to the B person, and then because B and C are mutually trusted, I can now send them the B token to the C. So in a way, as long as you're not connected, you cannot do transitive transfers. Like you cannot do the transfers between 2 people, which is why there's another important aspect of circles is to be the part of the network to whom you're expecting new tokens from. Now, How you can start with Circles SDK? Well, there is a text SDK for this, and there are some dependency packages, so you could install that simply and start working with it. We have a working docs as well, which shows you the implementation setup for the Circles. Now, what you can build with Circles protocol. So if you would go on ETHGlobal dashboard, you will see some bunch of ideas that we have pointed out. But I think one of the core things for Circles is how you can utilize that for forming groups and organizations. So there are 3 different avatars for Circles. There is personal, personal human avatars, and you also have groups and organization. If you want to form a group and you want to make it some sort of like a community socialized app, you can use that as a feature and start implementing the CRC tokens as well in the whole flow. Also, there is a group tokens for the people who are part of this network, which will be exchanged as your personal collateral from your personal Circles balance. So if you had to invite XYZ people to your Circles group, they would have to spend some of their tokens and then be able to mint the group tokens. Now, moving on to Gnosis Pay, I think some of you might already know, but if not, Gnosis Pay is like the first a debit card, self-custody debit card, and it's supported by Visa Network, and it's on Gnosis Chain right now. So the way Gnosis Pay cards exactly work is, of course, it uses Safe account. So your Safe Smart account is the basis of where your token balances stay. Right now, there are 2 token balances supported. One is EUROE, the second one is GBP. And on the top of your Safe account, you have these 2 modules, the delay and the roles module. If you are a payments person or you want to build like a consumer-focused application for payments people in general, I think this is a very amazing track for you to build upon. So the delay module allows you to delay the transactions by 3 minutes. The reason we do that is because Visa takes about 3 minutes to confirm the transactions, while Gnosis Chain transaction times are up to 5 seconds. So we don't want you to double spend, and that's why we implemented the delay module on top of it. The roles module keeps a check of which tokens you are basically transferring. So let's say if your Safe Smart account has USDC, USDT, or any other tokens, it will only make sure that you can spend EUROE and GBP tokens for the transactions. So there is also like GitHub link if you want to take a look at, feel free to do so. But you can also create your own custom modules. For example, if you want to build like a savings account or you want to like do some kind of yield-bearing token implementation here, you can have your own custom module here, but you have to make sure that it does not comes in the middle of the delay module, because it should be able to verify your transaction settlement and in general like the source of transactions. Now, to build with Gnosis Pay, we have few things here. We have Gnosis Pay APIs. We also have Gnosis Pay account kit that you can improvise with. In the simplest way, if you don't want to go too much into tech or it's your first time hacking, I would 100% recommend to go from an API perspective or just use Safe Smart account with these modules in general. And I think that would be like the most simplest way for you to start off with. Now, I just want to give like a small flow because I think we still have some time, so maybe this can be helpful for you. So for Circles docs, I wanted to give an overview in general because, as I mentioned, you would have to be invited to the Circles network, but we wanted to simplify it for the developers. So here is what we did. We have a version of the smart contracts, which is inspired by the main Circles Hub V2 contracts, which allows you to self-register yourself. It's not your actual Circles account, but it does work in the very same way as a normal Circles account would work. So once you have like set up your entire SDK, which you will find here, once you have set up the entire SDK in a proper format, what you would be doing is you would have to pass your inviter address. Now this inviter address would resolve to 0x00, like here. So if you just pass 0x00 as your address and then pass your name and then do a self-registration call, then you would be able to get to be part of the Circles network. So you would basically would not have to depend on our team or like getting invited to the network in general. And apart from that, you can also find group avatars and organization avatars. You can also query the Circles data as well and look at some of these interfaces, methods. There are also some past hackathon projects available on Circles that you can simply start building with. And yeah, I think this is it for the circles. I want to like take a lot of questions from audience. So yeah, if you have any questions, please do so. You wait a minute.
How is the value for the personal tokens determined? The price, like for the CRC, like the tokens that you can.
Can you speak a bit louder?
Sorry. How is the value of the personal tokens determined?
Well, currently it's not. There is no there is no token backing yet that we have started. But maybe in future or course of time, we would be able to define the value of each circles token, which is the sort of one of the other use cases. Right now, like it's just that if you want to exchange tokens or you want to send tokens, consider that if there's a service for, let's say, 50 CRC tokens that you want to give away for, you just pay 50 CRC tokens. We did something like this in DAppCon long back where you could like buy gelato, ice creams for 50 circles tokens. So yeah, there is no DeFi value right now present, but soon maybe in future course of time. Yeah.
So hello, there's a question regarding the Gnosis Pay. Is Gnosis Pay and these circles related, or in what way are they related?
Not directly, although if you want to build something that has got to do with, like using circles for safe account and then giving them as an incentive value, then for sure, like if they want to get some reward points, then the circles token can be converted into XYZ format and, you can use that for Gnosis Pay account. I mean, there's not DeFi flow available yet, otherwise you could have exchanged it for EUROE or GBPE balances right now. But yeah, they're not correlated, although they both exist on Gnosis chain. So if you have some specific idea and you want to improvise on that, we are very happy to help you.
Thank you.
Thanks. Any other questions?
Yeah, so you showed an example where you wanted to transfer 100 tokens from person A to person C. So why can't we transfer the tokens directly from person A to person C and like there's a need of mediator like person B in the middle?
Okay, so the idea is there is a path transfer between these people. Okay, let's say you are the person C, I want to transfer it to you, but we are not in the direct touch. So the way Circle's token flow works exactly is there needs to be a trust path. If it's able to find a valid trust path, which means I'm connected with you, and for me to send you the tokens, you need to trust me. Okay, so if on the path transfer it cannot find that you are willingly trusting me, I cannot send you the tokens. The way it would work is I can find a common path. So let's say the person who's sitting right next to you is the common person. I can send the token to him, and he can send you the tokens, forwarding it to you. So there needs to be a path transfer in the middle. There's like a Pathfinder infrastructure in the backend as well that's using the trust connections and then sending these tokens in general.
And like, how can we make the trust connections? Like suppose if the person A wants to make the connections with the person C, then how can we do that?
You can basically, so there's trust and untrust call both on the V2 smart contract, but you can call that function from within the SDK. So if you want to invite a person or you want to trust a person, you can just simply call that function directly from the SDK, and then this person will start accepting the tokens. Okay.
Thank you.
Okay, cool. I don't have a very specific technical workshop here because most of the things are present in the docs itself. But I would definitely recommend for anyone who wants to start building with circles to join the Discord channel as well. So we just started off with the Circles Discord channel. There's also a Telegram handle for Gnosis Pay people, for all the Gnosis Pay builders. And we have a Gnosis booth. So if you're looking for Circles or Gnosis Pay support, please please do find us on the Gnosis booth itself, and we'll be very happy to help you. And I hope you have a great time hacking. And yeah, like just build out things that you love. Thank you.
Hey everyone, my name is Kirill. I'm the head of research at BlockScout. So let's jump into the BlockScout workshop. So if you haven't heard about BlockScout before, BlockScout is a most widely used open source blockchain explorer for EVM networks, rollups, mainnets, devnets, anything EVM related. So in this workshop, we'll talk what is BlockScout and why you should care about it, why you should use it, why chains should use it. We'll talk about the APIs that are available to the hackers throughout this hackathon to be eligible for a BlockScout bounty of 20K. We'll talk about the contract verification, which is also one of the requirements to be eligible for the hackathon bounty. And then we'll talk about the bounty in a bit more details. So why should you care about BlockScout? Basically, in the past couple of years, we have seen this exploding growth in the number of networks launched. Basically, everyone is now launching their own rollup based on OP Stack, Arbitrum, and so much more. Everyone is having testnets, devnets are being spun out and shutting down. Basically, only throughout this week, we have seen a couple of, I think, 5 network launches or something. And so for all of these networks, any network which is EVM compatible and even not EVM compatible, it needs some sort of block explorer. And so there exist a couple of proprietary solutions, but it's obvious that they are too expensive for everyone to use. They are too rigid, too hard to launch. They cannot be launched quickly in a matter of few hours. So the only feasible option we see here is that there should exist an open source blockchain explorer that anyone can use for free, that someone may host for a small fee, but open source explorers are just something that any blockchain page should absolutely have. So BlockScout has been very successful in its journey and is now being used by more than 1,000 different networks. This includes all the different mainnets, devnets, testnets. Some of these networks are hosted by us, some of them are hosted by different other providers, rollup as a server providers and something like that. And then the most majority of these BlockScout instances are self-hosted by the teams running the chains, by the teams operating their rollup sequencers, and they run it absolutely for free on their own infrastructure, in the public cloud, in a private cloud, and there is no limits where you can use BlockScout. So BlockScout is fully open source. It has a bunch of different components that are all open source that can be configured and optimized and customized for the specific needs your chain have. It has a bunch of different models that can be turned on and turned off for the specific chains, for supporting user operations, data availability indexing, and so much more. It's user-friendly, it's dev-friendly, it has a lot of contributors from the open source space, so BlockScout is fun. So now let's get back to the work, to the hackathon, to the bounty, and what you should use throughout this hackathon to be eligible for the BlockScout bounty. So we'll start with the APIs. What BlockScout APIs we have that are available to the hackers, what can you use, some different use cases for them. So we have a bunch of different types. So let's start from the first one, which is the REST API. So basically we have this public Swagger on every of the BlockScout instance. You can go and see through a bunch of different REST API endpoints. Basically all these endpoints are the ones that power the BlockScout UI itself. So all the information that you see in the BlockScout UI, such as the address info, the number of transactions, the transaction list itself, the source code of a particular contract, the different token transfers, NFT transfers, and basically anything you can find throughout the UI. This is all fetched through the BlockScout REST API, and you can use the same info you see in the UI by looking and finding the respective API from this list. And then if you like a little bit different format, you don't like REST APIs, you can pretty much use the same data and query it through the GraphQL interface. So among those REST API endpoints I mentioned on the previous slide, one of the most recent additions to that list was the transaction interpretation endpoint. So basically this is a simple endpoint that is available on most of the BlockScout instances that allows you to pass a random transaction hash of an existing transaction on this network, and then the BlockScout will collect a bunch of different data about these transactions, what happened in it. This data will include some low-level information, raw information, as well as decoded info about logs, token transfers, the called smart contract method, and it will use then LLM model to aggregate all of this data and to categorize and trying to interpret this transaction in an easy to grasp and easy to understand format that can be displayed within a couple of lines to the user, just to give them the idea what actually happened inside these transactions. So whether some token or NFT was minted, transferred, maybe something got burned, maybe some tokens were swapped, or just a random unspecified method was called on a specific contract. So what this API does in the end is you give it transaction hash and it outputs you one of the templates from the fixed set of templates we support and have. And then, so it outputs you the template string you can see on the slide, and then the variables you should fill this template with, such as what's the token name, the token amount, the NFT ID, and stuff like that. So if you want to display some summaries of transactions within the UI or something like that, you can use the Block Scout REST transaction interpretation API and microservice for that. So then the second API model we have at Block Scout is an RPC compatible API. Basically, this is the API that you may be familiar with from other explorers. So a bunch of different explorers support this API format. So if you have some library that operates and uses this particular API format and you don't want to rewrite it, to fork it, you just want to use it as is, or you just very confident, you feeling very confident about using this particular API type, basically we support it too. You can use it to query pretty much the same information that is available through the REST API, but in a slightly different format through the different API query parameters. But again, that's just a different interface. You can query all the tokens, token transfers, logs, information about accounts, blocks, contracts, transactions, anything. And then the last API we have available at Block Scout is JSON RPC compatible API. Basically, it's the same API you use when connecting to the raw JSON RPC endpoint. But here, so we support almost all of the ETH namespace JSON RPC methods. And basically, the best usage for this API in your front ends, in your dApps, as a fallback option to the existing JSON RPC provider. So if you're using Infura or something like that, you can add at the end of the list as a second fallback JSON RPC provider, the Block Scout, JSON RPC endpoint, and your app will just more redundant, it will be more available, and will use an additional source of information for querying its data if the first one goes down, doesn't respond, timeouts, or something happens. So that's pretty much it about the APIs available. Now let's talk about the contract verification for a bit. So the idea behind contract verification is that we are trying to verify the contracts that are available on the network in the format of bytecode. We are trying to match them with the specific source code that you have used to compile to deploy this bytecode. So the way it works is that once you have an unverified bytecode on some of the networks, we support, you can go through the UI or through different CLIs. We support that I'm going to talk about a little bit further down the line. And you just send your source code files. You specify the settings you use for the compilation, such as the Solidity version, the number of optimizer runs, and so on. And then the Block Scout backend will compare it will recompile your provided source code and compare if the bytecodes match to what we have seen on chain. And if it does, then you will see this beautiful green tick in the Block Scout UI, and the UI will tell you that the contract is now verified. You'll be able to browse through its source code. You'll be able to interact it with the read and write contract tabs, and yeah. So actually, in many cases, Block Scout can automatically verify and import some contracts that it has seen already in the past on either the same Block Scout instance under the different address. So for example, if you deploy same contract multiple times to just test it multiple times again and again, high chances that these contracts will be automatically verified because the bytecodes are identical, and if you verify the first one, then the second and subsequent ones will be verified automatically. Then we're able to import identical contracts also from other Block Scout instance connected through the Block Scout bytecode DB database. Then we're able to automatically import smart contracts from other source code verification providers, such as Sourcify. And then in the future, this source code import will be also available to, you will be able to directly import any verified contract through that was ever verified on some other different networks through some other different block explorer. And this will all work with the help of the Verifier Alliance initiative, which is basically the idea that we want to create this shared database of all verified contracts. And we are working on it with a couple of different partners, RouteScan, Tenderly, Sourcify, and BlockScout. So this is coming very soon. And if your contract is deployed for the very first time, then you'll have to do some manual actions to be able to verify it. So basically, there are a few ways you can do it. So the simplest way that works best for small and single file smart contracts is you can just go to the BlockScout UI, click some buttons, fill in a couple of settings, submit, copy-paste your source code, and verify the contract through the UI. So this works best for the most simple contracts and for Viper contracts. Then you can build your custom verification pipelines by using the raw BlockScout API for the verification. You can verify via any verification plugin, for example, in Sourcify, and then import the contracts into BlockScout. This works well too. You can use some automation tools or dev frameworks to verify and automate your verification too. So if you're confident in using Foundry, there is a flag for that, for verifying your contracts automatically using Foundry CLI. There is the same for Hardhead. Or you can use some automation tools like Catapulta to verify your contracts automatically on multi-chain deployments. And if you want to learn more about the Verifier Alliance initiative, please scan the QR code and follow the news, join the community, and see what's going on there. And the last point I want to talk about in contract verification is that we also support a bunch of different proxy patterns. So proxy patterns is a very common way of deploying contracts nowadays. So whenever you want to do some upgradability stuff or you want to reduce the on-chain footprint of your smart contracts to reduce the gas cost and so on, that's the typical use case for proxies. So, and there are different proxy types that we support. There are immutable minimal proxy standards. There are some storage slot-based proxy standards that put the implementation address under the specific slot. And there are a few others, and we support all of them. The BlockScout UI will automatically detect, so you don't have to click any buttons to detect this proxy. It will be automatically detected once someone opens this contract in the BlockScout UI. And we'll conveniently show the detected proxy type. The UI will also allow you to interact with the underlying implementation directly through the UI when you are going to the proxy address. So now a few quick words about the bounty we have. So we have a very simple bounty throughout this hackathon. So basically it's a 20K of the pool price and that's it. And we're gonna split that evenly across all qualifying projects and teams that qualify the following requirements. Basically, depending on the specific you're building or specific projects, we understand that everyone has their own requirements, their own needs. Some teams have smart contracts, some don't. Some need APIs, some don't. So just try to use BlockScout as much as you can throughout your project. If you have some smart contracts, go ahead and verify them. Check that they're verified in BlockScout. Try to interact them with BlockScout. If you need some data, such as token transfers for a specific address, use the BlockScout API to query that. If you have some links linking from your dApp to on-chain transactions that the user submitted through the on-chain wallet, you can put the BlockScout links on that after the transaction submission. If you want to include your dApp in the BlockScout dAppScout marketplace, which is a marketplace of dApps we have for a bunch of different networks, you can also fill out this marketplace submission form. And basically, the most important requirement after that is we just want to see how you use BlockScout in your final presentation. Either it's going to be live in front of our desk, or when you record the video, just mention how you use BlockScout, interact with the BlockScout when you go through and show a bunch of different transactions to the judges. So just show how you use BlockScout in your final presentation, and that's it. You're good, you're qualified. You'll definitely get a share of this 20K prize. So that's it for this workshop. If you have any questions, please ask. Otherwise, happy hacking. Join our communities. And if you have questions after this workshop, please come to our booth, or if nobody is there, please ask them in their ETHGlobal Block Scout partner Discord. All right, thanks guys.
Hello, welcome to Intro to Rust Smart Contracts with Arbitrum Stylus. So in this workshop, I hope to go over just how to do kind of basic Rust and just get you kind of on-ramped enough to, kind of understand the easy parts of Rust, I guess, enough to like get you comfortable if you're working on a hackathon project for, we've got like, Arbitrum has $18,000 towards Stylus grants for this hackathon. So and usually these tracks don't get a whole lot of applications compared to a lot of other ones. So usually if you submit something, you got a pretty decent chance of winning a prize. So this can be a highly useful skill, and it's something that I hope, like, if you know another language and you're not really familiar with Rust, I hope you can like at least understand a couple of the basic parts of Rust to, if you know something else like Java, JavaScript, you should be able to get on-ramped enough to build something for this hackathon and put something together. And it shouldn't be too intimidating for you. So we'll just, we'll kind of stick with Rust, the easy parts for this demo. But yeah, that's my name there. I go by Crisco. Crisco512 on Twitter and also Telegram. Feel free to DM me. Yes. Oh, I'm sorry. Share something? Yes, that, right? Yeah. I'm just, yeah. I'm about to change the slides. All right, thanks. So what is Stylus, by the way? If for those not familiar, it's a parallel VM that runs on Arbitrum chains. And essentially it runs as a sister VM to the EVM on Arbitrum chains. And that means that you can, when a contract is compiled in WASM and deployed on chain, there's a small little header that gets deployed with the bytecode, and Arbitrum will either run it in a WASM context in the WASM VM or the EVM, depending on what that bytecode gets interpreted as. And it remains fully composable with the EVM, so it's not like a separate execution environment altogether. It still shares a storage state with the EVM, so you're able to store data in the same co-locations as other Solidity data. So it's just fully composable with Solidity, and as you can see, other languages are supported. We're going to go over Rust here, but you could also use Zig or C or AssemblyScript or any other like systems type language that compiles to WebAssembly. It could be very powerful for that. But for we just built the Rust SDK for now as a central focus for us. But we are excited to support other languages in the future. But for now, we just got our Rust SDK to use. But the main benefits of Stylus is that you get access to 70 times more compute per unit of gas versus the EVM, and 1,000 times more memory. And that's because the WebAssembly VM runs closer to like bare metal assembly instructions. And so there's less virtualization and things like that going on in the Arbitrum nodes. And we pass those gas savings on to developers and to users of the blockchain. So whenever you're doing something computationally heavy, Stylus is a prime, that's where it shines. Storage costs tend to remain the same as Solidity costs. So if it's just a storage heavy, or just it only has like a few additions, subtractions, that sort of thing, it might not be a big gas savings versus Solidity, but it still can enable these other languages if you want to build in other type-safe languages like Rust. So it can be useful for writing safer contracts and things like that as well. Yes, going over, it supports alternative coding paradigms, helps onboard developers from Web 2, and we want to get access to the 20,000 Rust devs that are out there, and there's also hundreds of thousands of other developers in other languages we'd like to onboard. So these are kind of why we built Stylus on Arbitrum. All right, so to get started with it, your primary resource for working with Stylus will be docs.arbitrum.io. And in there on the sidebar, we have a section called Write Rust Smart Contracts, or Write Stylus Rust Smart Contracts. I forget what it says, but it'll be on the sidebar. You click into that, And if you go into the quick start, you'll be able to, you can follow that to like get all the prereqs installed in your system. You'll need Rust installed. You'll need Docker installed in your local system. And Rust Up is the CLI tool. There's a couple of CLI tools that will come in handy. But just follow these instructions on there, and it's very easy and quick to get going. Yeah, there's another section of the docs called Run a Local Dev Node, and that's going to explain how to get a virtual Arbitrum node set up on your local system. So for quick deployments and for the purposes while you're at this hackathon, you'll just want to work locally against your local Stylus dev node or Arbitrum dev node. So look for that section either under the Stylus section, or I think it's also somewhere else. But also, if you, for the purposes of the hackathon, if you want to submit on the price track, you'll want to deploy it to Arbitrum Sepoya. And here are 3 faucets you can use. These faucets are also listed on the docs at arbitrum.io. So if you need some testnet ETH, and also if you need more than what the faucets are giving you, just reach out to us or come to the booth, and we'll send you some testnet ETH. So just let us know. Okay, so again, Rust's primary advantages over many other languages, or over some other languages, is that it's a very strongly typed language. It's memory safe. It's got a lot of high-level language features, so it kind of feels more like a modern language like Java or C#, or it's got a lot of high-level features, but it still remains a systems-level language, so it runs close to the speed of C or C++. So it's very fast, it's very efficient. So Rust has been growing rapidly over the past few years for those reasons. It also has a very powerful compiler that will a lot of times just let you know specifically what line of code is incorrect, and so it's a very helpful compiler. It also has like some cool features like pattern matching. As I said, it's very fast. These are kind of how you work with variables in Rust. You can either define, variables are actually immutable by default. So when you say let x equals 5, that's an immutable value. But if you say let mute x equals 5, that's a mutable value now, and you can now mutate that value. These are some of the data types that you have access to by default in Rust. These are unsigned integers. By default, Rust supports all the way up to unsigned integers of 128 bits. But for Stylus, we have a library that we bring in called Alloy. That's from the Foundry team. But we use it as part of our SDK to give support for 256-bit integers, since you need to maintain that Solidity compatibility. But these are, this lowercase u, these are the native Rust types. So sometimes when you're working with SDK, you'll need to parse from native Rust to Solidity types. But I'll get into that later in the demo. But these are just the native Rust types that you kind of have access to. This is what booleans, characters, tuples look like. A tuple is just like kind of a set of values, and arrays. This is what a function looks like. It's very simple. F in main, you print line, call a function. So again, this is just working with functions, very simple. And for the most part, for the hackathon and whatnot, I would recommend just kind of sticking with basic functions, calling other functions, just to keep your code simple and straightforward. This arrow syntax, where you see the +1 function down there, that's how you return a value. So you just use that arrow syntax to indicate the return. This is a struct, so this is if you're setting up a data struct. You'll use structs quite frequently in Rust. This is just a rectangle with a width of with a 32-bit unsigned integer for both width and height. It's very similar to objects in OOP languages like Java or whatever, but they are slightly different. Rust tends to eschew things like inheritance as a design principle, but so a lot of times with Rust adopts something called composition over inheritance. So a lot of times you'll just attach methods to structs. and you'll implement traits. But I don't know if I'll get into that too much in this talk, but yeah, like just know that traits are kind of like interfaces in other languages, and you can implement traits for structs in order to create behavior for the rectangle, like a computing area or something like that. Yeah, this is just giving an example of declaring a rectangle. There's multiple ways to do this, but this is just one of the default ways to declare a rectangle and instantiate it. Yes, what I mentioned earlier with impling. So right here, what we're doing is we're creating an area method on this rectangle. So we've got the rectangle struct that we defined above, and then the impl rectangle. Impl, you can think maybe implement. Like it's just impl rectangle. This is how you by default attach methods to a struct. So you just impl for that struct, and then you just define your functions down below. And that and self is a reference. That's just a reference to the instance of the rectangle itself. So that's always the default first parameter, and it's a reference there that you reference for the first parameter on the method. So that's very straightforward. Self.width times self.height gives you the area, which returns a U32. Rust also has access to something called enums. Enums are very powerful in Rust. They're very simple to declare. You can also impl things for enums. Right here, and enums are very powerful for pattern matching in Rust. So what you see right here is an example of pattern matching where we got a coin type, coin enum, and then we've got value and cents, and we're just matching on that value, and then we've got all the matching arms of that enum that could possibly be. And Rust forces you to always handle all the possible enumerations. So you always have to either explicitly declare each value, or you can provide a default arm on that match statement if you need to cover just the basic default use case, if you only want to define one for like penny, for example. Okay, so this is some control flow, kind of more advanced control flow type things you can do. You can say let config max equals sum 3u8. So what that statement is saying is that if that config max is going, if it has a value, like if this is Rust has this option type where it can either be none or something, and that sum keyword is just like it will, if this value has something in it and it's not if it's not the none type, then it will match on that sum branch, and it will what this is doing is matching on config max, which we already assigned it the value of sum 3u8. 3u8 is an 8-bit unsigned integer with the value of 3, and we're matching on that config max, and then given that it is something, we're going to parse that value out as max, and in that matching branch line right there where it says print line, that would print out the number 3. So yeah, this is just a little bit more advanced syntax, but takes a little bit getting used to, but it could be very elegant when you need to make use of this. But I highly recommend learning pattern matching as you get more advanced in Rust. As I said earlier, traits are kind of like similar to interfaces in OOP languages. So this is how you define behavior for structs or enums. And so right here I've got this summary trait with a summarized method, and I'm just declaring the interface for that method. It doesn't take any parameters. It receives a reference to self, but it returns a string. So that's the summary trait. All right? And this is an example of that in use, where I've got a tweet struct with username, content, reply, and retweet. And I'm then implementing the summary trait for tweet. And on that method, so that I'm implementing that summary trait. And that gives now that tweet struct has that behavior, the summary behavior. So I'm always, with an instance of tweet, I can now call tweet.summarize and get the username and content back printed to the console. That's essentially what this does right there. Macros are a powerful concept in Rust. What this does is allows program code to be generated at compile time. This is not something you'll learn if you're new to Rust. You won't probably be able to learn this this weekend, for example, but you will make use of macros, and you'll see them in practice. So when you see this exclamation point, like print line with an exclamation point on the end, that is a macro being invoked. And also, there's multiple types of macros. The exclamation point indicates that it's a function-like macro. And so print line there is calling the print line macro function. And then it's what that's going to do when your code compiles. It's going to almost like generate code in the background, and then it's going to like kind of remove that line and then stick that code right there before it compiles down into regular assembly or whatever. So so that's what you need to think of as when you see macros, just note that in the background when you're compiling, your code's going to be sort of like swapped out with the code that gets generated by that macro. And same thing with the hashtag, with the brackets, derive, debug, or whatever. If you see that syntax, that's a macro, and that means that the block after that, so that's usually like almost like an attribute-like macro. And those are usually attached to functions or attached to structs. And that's just going to, a lot of times it's just to like, it'll save you time from writing a lot of boilerplate that you would otherwise have to write. So macros are really powerful, really useful. If you're new to them, just note that, this is what's happening. But it does take a while to fully wrap your head around macros if you're totally new to them. We do make a lot of use of macros in our SDK, and I'll go over some of those in just a second. Okay, so we wanted to do simple design patterns with our stylus Rust SDK. We made use of Alloy, which is a primitives library that is gives you access to swap between values, between Solidity compatible values and Rust compatible values. And I'll show you that in just a second. When you're working with stylus, you'll want to use Cargo stylus. Cargo is Rust's CLI tool, and if you just if you want to create, once you've installed that locally, you can just call Cargo stylus new my first contract or whatever, and it will create a little basic counter contract locally. And I'll show you that in just a second. As you're working with your contract and as you're editing it, you'll want to call Cargo stylus check every so often just to make sure you're fitting within the blockchain constraints, because we do have some constraints on chain. Contracts need to be under 24 kilobytes, and we have to we do some compression, so it can be a little bigger than that. We do run some on-chain compression to try to get it under 24 kilobytes. And running Cargo stylus check will just make sure that your code is still under the limits. If you need more than that, you'll have to break it up into multiple contracts. Once you're ready to deploy, you'll call Cargo stylus deploy with an endpoint, a private key, and it will deploy to either your local chain or a remote chain. These are some of the primitive types, like I was saying earlier. When you're working with stylus, you'll use these alloy types. So you'll use this capital U8 and this capital U256. Remember, earlier it was lowercase u. That was the native Rust integers. These are library integers from our SDK, but they are built on Alloy. So these are Alloy types. And essentially right here, I'm declaring an 8-bit integer from the number 1. So that's just how you work with our stylus SDK integers. So sometimes you'll need to parse from one to the other, and that's how you do it with that U8 : from 1 or whatever to parse from native Rust to Solidity types. This is how you do addresses in Rust. You'll use like Solidity style addresses. You'll use that address type, and you'll : from, pass in well, this is just like filling all 20 bytes with ones. So that's an example of how to do a quick one. But you could obviously fill out the whole range of the 20 bytes if you wanted. Right here is, again, local variables. Oh, yeah, these are the different types of variables that you'll work with. Local variables, which just use memory. State variables, which use state and store on chain. And then global variables, which are values available in the VM. So those are usually referenced from within the SDK itself. You'll just pull those in as library values, and then you can reference those. Okay, remember earlier I was showing you that hashtag with the as a macro type. So that what you're seeing right here is Solidity storage macro, and what that means is we're declaring a struct type right here. This is us setting up our state for our smart contract for how our state's going to be laid out. And that Solidity storage macro is saying to Rust, this is going to lay out everything in a Solidity compatible way. This is also going to be the entry point struct. There should be exactly one entry point struct in your smart contract. And that's kind of your top level struct. That's your root level struct, if you want to think of it that way. You can have other Solidity storage structs, but you just need one entry point struct. And so that's going to be the root. And so your storage is going to start with that initialized variable, the owner variable, and then the max supply variable. So you've got a Boolean there, an address, and then a U256. And those are the storage state on chain. All right. When you're actually, I need to update the slide. Sorry. This external macro is now called public, but I think both will still work. But we did deprecate externals just to kind of match more with Solidity. So use public when you're, and if you'll see it, if you just clone the default counter, it'll show public. So stick with that. But that public method, that public macro or that external macro, what we're doing there is we're implementing on counter, and we're setting up our public methods that expose basically our API, our Solidity API for methods that external users can call on your smart contract. All right, let's jump into the code. Yeah, those are price tracks, but let's jump into the code. I've only got a few minutes, so I want to hop over to that real quick. Okay, so real quick, I'm going to do cargo stylus. So this is this is assuming you have everything set up. I'm going to say cargo stylus new counter demo right here. And that should clone in, and I think I should have it over here. All right, so I'm going to click into lib.rs is the default main file that you'll be editing on your smart contracts. And just kind of walk you through this real quick. There's some comments up here. We'll skip past these comments. A lot of this is boilerplate code that you'll just leave in place. This is just so that you can export the ABI for your contract later. So kind of just leave that in place. These are our dependencies we're pulling in from the Stylus SDK. We're just pulling in unsigned 256-bit integers from the Alloy primitives library. And then this prelude star is just kind of bringing in a lot of different things that we can just reference, like this entry point macro and stuff like that. These commonly used things that we need access to. So that star just brings in those dependencies for us. What you see here is this sol storage macro. And this allows you to declare your types in a Solidity compatible way, right? So I think on the slide I used the Rust style way. There's two different ways to do it. But using this Solidity style, you'll actually use Solidity style syntax to declare your state, to lay out your state. So so that's exactly, we're essentially within this writing out Solidity, like U256 Solidity. So that's a 256-bit number that is going to track the state of our counter. And again, we attach this entry point. So that is the root level struct, the root level storage struct for our smart contract. Okay, and then again, remember I said it was external before, but it's public now. So just stick with public, and we're implementing for that counter up here that we declared. And we've got a number of public methods available, including number where we're able to get the number from the storage, the value of the storage. We're able to set the number to whatever we want. We can multiply it by a number, we can add a number, or we can just increment it by 1. All right, so the way that works in practice, so like, yeah, right here, we made these public, and that means it's going to get exported on the ABI. We also, for mutable functions, so this and mute syntax, and mute space self, that means this function is a mutable function. It mutates state, or it's able to mutate state. So when we're calling self.number.set new number, we are setting that number to that value in storage. So on chain, that will be stored on chain to whatever we pass in. Okay, getting real close to time, so I'm gonna breeze through this real quick. But CDLS, CD counter demo. Okay, cool. And we got cargo, stylus, deploy. Okay, so I think locally I have like some environment variables set up. This no verify syntax is just when there is a contract verification that can run locally that can take a little bit of compute time. If you want to just deploy real quick, you can skip the verification step. That'll come later if you want to verify your contract on Etherscan or whatever. But then, yeah, I'm passing in the endpoint with a local RPC variable and the private key, which is provided to you by when you set up a local dev node. If you look on the docs, there's a private key that's given to you with local ETH that you can use for that. So you'll use that private key to deploy, and it'll deploy locally. It'll look like this, and once it gets deployed, should be quick. It's compiling. Deployed. Okay, came out 7 kilobytes. So we're going to copy that address there. And I'm using the library called Cast, which is from Foundry. So I'm going to set this to our new contract. And then, so Cast is a great tool if you're, if you're, for either if you're working with Solidity or whatever you're working with. So it's a great tool for interacting with on-chain contracts from the CLI. So, I meant to do call there. I did send. So real quick, I'm just going to call the counter. It should come out to 0. All right, and then when I go up here and I click, this time I'm going to do increment. And then I'm going to cast send increment. Okay, so that actually worked on chain, and then cast call. Now if we call the number again, it should say 1, right? So it came out to 1 there. So again, if I increment again, it should be now 2, right? So that's how that's just kind of how you build. This is very, I think this is very approachable if you kind of stick with the easy parts of Rust. Rust can be intimidating, some of the more advanced parts of Rust, but I think, if this is new to you and everything, you kind of start with the basic contract and then mutate, add functions that accomplish what you want. But yeah, I think it can be doable even if you're brand new to Rust in a weekend. So yeah. So you can see a read. Yeah. Yeah, you can add numbers right there, right? So if I wanted to. I know. Yeah. Yeah. Oh, okay. Oh, I see. Yeah, you would just do this. You would do right here. You would just say yeah. You would just say U256 from 2. Does that make sense? Yeah. Okay. Yes. Thank you for that question. And sorry, unfortunately, I ran out of time, but appreciate y'all coming. And I'm happy to answer any questions afterwards. Thank you. Yes. Hello. Okay. So my name is my name is Ansho. I'm here to talk about hooks today. Actually, about multi-step intents. But before we do that, I want to explain what is an intent. And I will do it so with an example. I need to paint the wall of my house, right? So one potential solution is to ask this guy, Valentino Morris, which for now on we will call him VM. Valentino is not very smart. So what I will do is give him detailed instructions on how to paint the wall. So you have to hold the brush up and down, apply 2 layers of paint, and then use the tape to not make a mess. So the problem is solved. Is it? When I arrive home, I find the VM make this mess. What do we do in reality? We normally call professional painters. So this is a good option because, of course, VM, this Valentino is stupid, but also I'm not the brightest, right? So if I had to follow my instructions, because I'm not a professional painter myself, it won't take him very far. The painter, however, will have years of experience doing the job. And they can perform optimizations, like get cheaper paint deals, like, for example, doing bulk treaties, and then get more professional equipment, like paint guns. And they will be faster and cheaper options, especially if we let a collection of painters, a collection of workers to complete the job. Let's call this collection of workers from now on cow. The painter can screw us. Somebody can say, like, you pay them to paint a wall, you give them some money, and then they screw you. For example, they could do half of the work and never finish the rest. They can use less layers of paint or low quality paint. But this doesn't happen in reality because the painter is a professional and his incentive is to deliver a good service. So we can call them again and recommend this professional to our friends. What if the problem is not painting a wall, but it's something that is 10 times harder, or 100 times harder, or even 10,000 times harder? This is what in reality happens when we try to settle orders on chain. And this is due to fragmentation of the liquidity. It's harder and harder to find optimal solution. And this is even harder now that we have over 1,000 side chain, like L2s out there. So nobody can solve this problem on its own. So this is our choice. We can send the paint instructions to the VM, to Valentino, and get terrible results, or send a paint job to this collection of workers that would find the optimal execution. If I didn't hint it enough, this is exactly what we do in CowSwap or Cow Protocol, where we send an order transaction. So
we don't send our order transaction to the VM with the tail instruction of how to get the liquidity or execute this trade, but we send it to a collection of workers, which we call solvers. And these solvers have the incentive to do this optimal execution and can give all these nice features that users of CowSwap can benefit from, like MAB protection, gasless trades, surplus generating orders, optimal paths, and the better of all that we can adapt to price changes, gas changes, and path changes. So we enter into the multi-intent orders. This is the life of a cow order, the normal one. You need to validate the signature, and you transfer the sell tokens from the user into the settlement contract, execute there the interactions that acquire these buy tokens that the trader needs, and then send them by the buy tokens. So hooks are just 2 extra steps that we added into this process, and you can execute arbitrary call data before your order and after your order. And this is done inside a special contract called the trampoline that would protect it will execute the hook in the context of this contract instead of the settlement for security reasons. So basically, you can do any DeFi interaction before any CowSwap trade or after your CowSwap trade. And this is how it gets done. When you send a normal order, there's one field called app data that points to a document, a JSON document, with the hooks. And the hooks is just an array of this triplet of the target contract you want to invoke, the call data that encodes the function and the parameters you want to call, and then the gas limit, that is how much gas you're willing to pay. And remember, we are gasless, therefore this gas won't be paid in Ether or native tokens. You will pay it in sell tokens only if you trade. So we are very happy because we are releasing something really new. These hooks, it was no new, but now we can allow third parties to create hook dApps that are small UIs that people can inject in CowSwap itself. And this is what I'm going to show. So if you go today to CowSwap, you'll find this setting to enable hooks. And here you can find this button to add a pre-hook and this button to add a post-hook. These are the hook tabs that third parties can make, or hackers from this hackathon could be making. And remember, since a hook is an interaction with any DeFi protocol, we could you could be adding some execution you want to do with any protocol before or after. Here we have an example of withdrawing liquidity from our CowMM. The only thing I have in my wallet are LP tokens, right? And here, the developer of this Cow Hook app made this interface. So this is really an iframe running inside CowSwap, and there's like a thin library for the communication between the dApp that lives inside and the CowSwap itself. And the responsibility of this dApp is to create a call to pass the hook that at the end of the day is this call data encoding the function we want to call on chain. Here in the interface we can select how much we want to withdraw from this AMM. In this case I'm going to withdraw 50%, which will give me 136 cow and 0.2 GNO. So what I'm doing right now is, basically the hook app has access to the wallet, so they can sign transactions. So this is what I'm doing. I'm signing, not a transaction, sorry, a message. This is a message I'm signing. So for right now, we haven't done any call to any blockchain. We are just signing messages. CowSwap will, like the DApp has passed the hook information to CalSub, so they can we can simulate the execution on chain of this and calculate the tokens that will be withdrawn. These tokens are right now credited here, so they will be part of your balance. So even if you don't have any balance, because we are gasless, you could do the interaction that gives you the balance, and then you can do the trade. So right now I'm adding a post hook that will create a Llama Pay vesting contract. I'm just going to create a new mnemonic here and send it to this address that I just generated. Sorry, not this one. So what this post hook allows is to send a stream of money. Which money? The output tokens of the swap. So right now I'll put 3 minutes. I'm sending this GNO. Again, I'm not sending a transaction, I'm sending a message that will be also simulated in Tenderly. And I'm ready to post this swap. Still, I haven't placed any transaction, but I just placed a meta transaction that the solver will be trying to solve. If we look in the Explorer, we can see all these hooks here. And this is what you really need to do. And there's a lot of tutorials. At the end of the presentation, you can see the tutorials and all the resources. Because we made this easy for you. If you want to, well, this order was executed, and I'm supposed to have these tokens already in the new wallet. So I could actually import this wallet here. And I can remember, this is a fresh account. I'm using the fresh account. I don't have any tokens. And what I could be doing is claiming in a gasless fashion without any native token, any Ether, any XI, anything, the vesting amount. You can see it. You can see how the connected wallet, that this new wallet has these tokens, this GNO has been received, and now is vesting. I could claim it. Let me get the contract of this, sorry. That's an easy way to get the contract. And I can put it here. This adds the pre-hook, and look what happened here is that I can claim already this GNO. Like I can select it here, the GNO, as a sell token. Maybe I select the native token now, and this is one super cool way. Let me cancel this one and sign this other one. So I just posted another order that will give me native tokens on the vested GNO that I received from the other token without having any Ether. So this is the promise of a gasless experience and what we want to provide in CalSub. One more thing, these hooks, if you want to list your application there, you don't need to ask permissions. You just add your custom hook here. We have examples on a tutorial how to add it, but just add the URL here and it will be loaded. That's all I wanted to show. There's one more thing. These programmatic orders is the other product that gets you a prize in this hackathon. It's basically something that allows your smart contract to get kind of superpowers to create off-chain orders inside the CalSwap. The only thing you need to do is to implement two functions. Really, is valid signature that will that needs to say, well, is the one that has arbitrary logic to say if your order is valid or not valid. So as long as you provide your custom logic there, then you can place your order. And then this other function that is get tradable orders that should revert if your contract doesn't want to trade, or should return the order that you want to add into CalSwap. And there's this off-chain component called Watchtower that will be creating the order for you. So there's no infrastructure you need to deploy. Join these two things together and you have a loyal broker working for you 24/7, placing the order when the time is right. And this is not just theory, but we have swap orders working already in CalSwap, and a lot of implementation of different smart orders. So the takeaways are, let me present again. So the takeaways are, same as we would delegate hard jobs to professionals, we should delegate execution to techs. This brings power and protection to users and all the features people love about CalSwap. Hooks allow us to extend intents, allowing you to do DeFi interactions before and after the trade. Make your own hooks by simply calculating the call data and attach it to your order. Extend CalSwap with small pieces of UI, as I showed before. Programmatic orders will give you your smart contract the superpower to create off-chain orders at the right time. Thank you very much. We prepared some documentation for you. If you scan the QR, it will be better explained than. Thank you. I don't know if there's any questions. Yes.
Hello. Yeah. So in the post hooks, the settlement layer transfers the tokens to the hook, right? And then the hook trampoline calls it, correct?
The hook is called by the solvers. So because when you
At the contract level. So
at the
contract level,
yeah.
so the settlement layer transfers the funds to the hook, and the hook trampoline contract calls the hook, right?
Exactly. Yeah, basically you said it correctly.
Yeah. And what about the pre-hooks? Pre-hooks, so the token transfer gets transferred from the user's address to the pre-hook account, right?
Yeah, I really can't hear the question.
What happens? How does the fund transfer happens in the pre-hooks?
Yeah, so the pre-hooks, you have arbitrary logic. So technically you can, the simplest case you can think is, for example, an airdrop. If you have a permissionless airdrop and I can claim for you, I only need to encode the call to claim airdrop and pass your address. So because this call data will be called in the moment of settling this settlement by the solvers, then the transfer from the airdrop contract will flow to you. And then you can decide what to do with those tokens.
As folks join, I think we're good. Hey everyone, small audience, but the best audience. So I'm Itai from Dynamic, and what I want to go through is kind of how to get started with Dynamic. So let's get through the basics. So first, a little bit about me. I'm co-founder, CEO of the company. What is Dynamic? Just so everyone's on the same page. Think about us as the crypto-enabled stack. So everything you need in order to kind of build these magical experiences where crypto is either in the center or in the background, right? It's used today by a bunch of projects, Starkware and Magic Eden, Eclipse and Animoca, and you know, Lamborghini and their Arena and Doodles all use Dynamic on their website. Just for context, in ETHGlobal Singapore, 7 of the 10 winning teams built with Dynamic. Now, correlation does not equal causation, but I am very bad at understanding which is which, so maybe it's good. Now, let's dive into it. So before I actually show this video, let's actually go through some examples of how you can use Dynamic or how Dynamic is used in the wild, and we'll dive in. So a couple of examples. So first, who has used Magic Eden before? No? Yeah? Oh my God, okay, fair enough. So for those that don't know, Magic Eden is today, I think, the highest volume NFT site in the world. This is Dynamic. So Dynamic is, on the one hand, a very fancy multi-chain wallet adapter that Magic Eden uses across Solana and Bitcoin and EVM and a bunch of chains. You can do really sophisticated things like connecting, kind of, you know, handling, obviously switching networks, but also more sophisticated stuff, and you'll see this in a second, like connecting multiple wallets to the same account. So creating kind of unique, very advanced experiences for Web3 customers. On the other side of this is customers like Doodles. Who's heard of Doodles? No? Okay, fair enough. So Doodles uses Dynamic, where you log in with an email or with Google, and essentially we generate a wallet in the background for you. So a customer coming into Doodles doesn't necessarily need to know they have a wallet. They just log in with email, and that's it. They can pretty much, at that point, interact with the site. So that's a different example. A third one is dflow. So dflow lets you kind of log in with an email address. Let's enter my email address. Let me grab a code. Let's do that. Let's grab a code. Okay, 68569. There we go. And at that point, I logged into the app, and I have a wallet here in the background. So if I now go and I say, look, let me actually buy some USDC with USDT, this is an example of using Dynamic in the wild. You know, let's buy. There's really no experience of a wallet here, right? It all kind of happens in the background. So this is another example of Dynamic. So Dynamic can be a very Web 2 experience where you don't see crypto anywhere, right? So you can think about it as embedded wallets that kind of just work in the background. You can see it on gaming sites like XP. You can see it on bridges like Eclipse. This is a version of Dynamic. Or Legion, or if you've heard of Maple Finance, or Doodles, if you go to their marketplace and click Connect, that's powered by Dynamic. So you can see it all across these experiences. You can see it on Barachain as an example. All of these kind of are different versions of Dynamic. And so Dynamic is really 2 parts. It's an SDK that you can implement into your app, and it's a developer dashboard. So we'll start with, here's the Dynamic SDK, and as the name suggests, it's very dynamic. So you can do pretty much anything you want with it. So you can change colors, and you can change themes, and you can kind of, you know, make it whatever version you want it to be. You can change corners, you can make it fully headless, anything your heart desires, right? You can also, let's change it back to a little bit more sane. Actually, let's keep it like this. You can say, look, I want only wallets, and I want them across multiple chains, right? Or I want the reverse. I don't want to talk about wallets at all, and I want to just have email and social login. And you can do it this way. You can add wallets, and you can collapse them. You can show them this way. Whatever your heart desires, you can pretty much do. It's a very, very flexible tool. Now, Dynamic lets you pretty much do one-click wallet generation. So I logged in. I generate a wallet, and at that point, I'm pretty much good to go. I have a wallet address. It can happen across EVM and Solana. You can do more fancy stuff like connecting multiple wallets to that same account. You can connect multiple login methods to the same account. So not just Google. If you're building a game, you can use Epic. Or if you're building something with music, you can use Spotify login. Pretty much anything you want to do. And it's non-custodial. So you can go here, export your key, and at that point, you're done. And you can take it and import it into MetaMask or Phantom or anything like that. So you can pretty much use Dynamic to abstract away complexity of crypto in your app. Does that make sense before I continue? Awesome. Okay, so we looked at the very basic stuff. You can do a lot more clever things on top of Dynamic. So you can start saying, look, I've generated a wallet for someone. Now let me connect it to Uniswap, right? So the wallet doesn't necessarily have to be siloed. So let's actually take an example. Let's go to Uniswap, right? Let's go to their app. Let's hit connect. I'll copy the wallet connect code. On mobile, by the way, this will, if you set up Dynamic on mobile, it'll show a QR code scanner, so you can just scan this QR code. I'm on desktop, so I'll just copy it here. And at that point, it'll kind of automatically detect it. Let me connect to Uniswap. And I can trade on Uniswap with my Dynamic embedded wallet. So it's not a silo wallet, but it's actually a global wallet. Again, if you set it up on your phone, it can add, just like a Rainbow wallet or anything like that, you can scan and interact with sites. So it can expand pretty quickly beyond just kind of embedded wallets to embedded wallets that can interact with other sites. So as you're building this stuff, for instance, I think we had a presentation here before from Cow Protocol, you can spin up an embedded wallet and have it connect to the protocol and do a bunch of cool stuff. Now, we saw the basics. Let's start building actual things, right? So I set up a very simple Next.js app, and I created a login with Dynamic. Email only to start, just so you see what it looks like. So I set it up. I pretty much have I import Dynamic. I pretty much set up my environment ID. I set up a very simple page, and I'm pretty much done. Now, you know what? I don't want just email login. I want to do more stuff. So let's go to my developer dashboard, and let's start toggling things on. So I want wallet login. So let me save that. And I also want login with Google and login with GitHub. Right? So let me add that. Right? And let's refresh real quick just to see what that looks like. I have some hydration errors. Let's ignore those. All of a sudden, I have wallets, email login, social login. Right? So I don't have to make massive code changes. As soon as you implement Dynamic, you can go to our dashboard and start playing around with things. So you can start kind of turning Epic Games or Discord or Telegram login. You can start changing the way things are displayed. So let's collapse the wallets list, and let's save that real quick, and I'll refresh. And if I now log back in, you'll see wallet list is behind this button. So you can really quickly customize Dynamic to your use case with a single, again, I have not changed the code at all, right? I set up 5 lines of code, and at that point, I just toggle things on and off. Now, let's get fancier, right? So besides just authentication, when someone logs in, I want to collect their first name, and I want to collect their last name, and I want to create a custom field. So let's create a test custom field, and let's make sure it's unique. Let's make it optional, and I'll save it. And at that point, if I refresh, and if I log in with a user that hasn't logged in before, so let's do Itai plus test at dynamic.xyz, right? And I'll send an OTP code to that. Let's grab the code, 1 second. Let me just grab my code. There we go. 495113. And at that point, Dynamic turns from just authentication. Oh, I might need to refresh. Bear with me for. Oh, I will need to do one more thing. Let's actually make it required. So I'll save this. I'll make this required as well, and I'll save these changes. and I'll log back out, and let's try this again. Bear with me for a second. Let's do this. So I'll enter a new user. Let's grab a code. Bear with me for a second here. Let me grab my code. I think this should. There we go. Okay, 737343. And at that point, Dynamic turned from just an authentication platform to information capture platform, right? So I can start not only logging in with kind of my user information, but I can start capturing additional information, whatever custom fields you want, right? And then you can set up webhooks, you can do a bunch of things. So we logged in, and at that point we have a user, we have an address, we have the chain, and we're in a good spot. Now, this is just Ethereum. I prefer additional chains. So let's go here, and let's kind of start toggling on additional chains. So let's toggle on Polygon and Optimism, and I saw Scroll is sponsoring, so let's toggle on Scroll, and I'll save this, and as soon as I refresh, essentially you'll see this. Let me just, I might need to log out and back in. No, I think I should be good. Now I have these chains, right? So again, I did not touch any code so far beyond the first implementation of Dynamic. I kind of set it up once, and I can start toggling on a bunch of things. Let's say I want to toggle on an on-ramp. I can go to configurations. I can toggle that on. Let me quickly accept terms of service. I'll kind of toggle this on. And at that point, if I kind of refresh, Dynamic will all of a sudden kind of have an on-ramp component to it. So again, no changes, pretty much straightforward. You know what? I also want to be able to link additional wallets to the same account. So let me turn on multi-wallet. I'll toggle this on. And at that point, my profile will change to let me link things together. Now, we talked about auth, but let's start. I think we have time, so let's start doing some interesting stuff. So let's add the ability to sign a message. So for the first time, I'll actually go to code. I'll do the fancy cursor thing where I just say, let's just try to implement a message. Bear with me for a second. Okay, so let's see if this works. So I'm actually going to use both ends. So bear with me for here. Add a sign message button using this code. Let's see what it does. So it added a sign message button. Let's accept. Let's save. Let's go back here. I'll refresh. I have the sign message button already. And at that point, I can sign a message. Right? So that was the entire extent of signing a message. I signed a message, and I'm pretty much done. Signing a message transaction took me a second. But I can take it a step further. So I want to sign a message, but I don't want that pop-up. So I don't like that pop-up. Let me just toggle that on, toggle that off. And on next signing of a message, it's just going to sign it. So, oh, actually, I might need to log back out and back in. Bear with me for a second. Oh, yeah, okay, so no more pop-up. So signing a message now would just work headlessly. Right? So again, one toggle, one change, and pretty much done. Now, let's take it a step further. So we signed a message. Let me now turn on the ability to connect to other wallets, right? So the ability to just set up QR connection. So I NPM installed my global wallet already. And all I want to do is essentially import this. And let's take the cursor fancy AI approach. Implement global connection. And let's see what it does. So I'll submit this, and it should import this. Bear with me for a second. I think let's hope for the best. Let's refresh. Oh, hold on. Oh, no, this is not going to work. I'll do it the old-fashioned way of actually doing this. So let's import import Dynamic. I'll do this here. And I will also add, oh, I should actually not do, oh, I see. Okay, I did this in the wrong spot. So let me actually do this here, remove it, save, and instead give the same instructions here. Let's see what it does. We should be good. No, I'll manually do it. bear with me for a second. I'll do this the old-fashioned way of actually writing code. So let's import the global wallet extension, and in the wallet connectors, let's add a global wallet connector, right? I should be good. Let's hope for the best. No, oh, okay. I will skip this part given we have like 5 minutes, but the idea is that hopefully with a few lines of code, again, not in this case, clearly this didn't work, but you should be able to, with a few lines of code, not just have the wallet siloed. 5 minutes, perfect. So not just have the wallet siloed, but have the ability to connect to any other site, add signing of transactions, signing of messages, pretty much whatever your heart desires. If you take nothing else away from this kind of presentation, you should take that Dynamic is an extremely flexible tool. It can be front and center. It can be very much in the background. If you want to build a game, it can happen kind of silent signing. If you're building a DeFi app and you need MFA, you can turn on Google Authenticator or passkeys for additional security. Anything you need, assume we can do, right? So let's summarize that real quick. So I'll show a slideshow real quick. So again, we saw DFlow already. A second app, if you want to play around with Dynamic, is Bags. If you're trading meme coins, check out Bags. You can very quickly kind of trade. Bags.fm is another good example of using Dynamic. And with this, I want to end with the following. And you can come to our booth as well, and we have guides. Here's the best way to get started with Dynamic. You can just scan a QR code for our docs. I'm willing to bet it's going to take you 5 minutes or less to actually set up. We have a few cool features that might be relevant for you in case you want to explore them. So I showed silent signing, so sign messages with no pop-ups. That's behind a feature flag. If you want that experience of session keys, of kind of you log in and there's no 2FA, reach out to us. Just come to our booth with your environment ID. We'll turn that on. Again, if you want another feature that we have, which I think is pretty awesome, I'm very biased, is a feature called Telegram Auto Wallets. So if you're building a mini app in Telegram, we can take the login information from Telegram and auto log you in and generate a wallet. So as soon as the Telegram mini app shows up, it will just log you in. You want that access to that, come to our booth, give us your environment ID, and we can take it from there. We have a bunch of prizes. I will end with one thing, and then we'll go on to questions. Shameless ask for my marketing team. Please follow us on Twitter. I will give everyone a second to QR code scan this. I've been told that that's the primary reason for why I'm doing this presentation by my marketing team. So I have no choice but to ask everyone to shamelessly follow us. And with that, I will open it up for questions. Any questions about Dynamic? Yes. 1 second, I couldn't hear you.
Do you have SDKs for Unity? You were talking about games.
Yeah, that's a great question. Not yet. I wish I could give you a Unity access very, very soon. Today, the SDKs we have is React, React Native, Flutter, as well as access, I think, alpha access to Vanilla.js.
Perfect. Thank you.
Yeah. But that is a very good ask, and yeah. Thank you. Any other questions? Oh, or no questions? Yeah. Yes.
Hi. Do you integrate with push for like notifications?
Yeah, not directly, but my understanding from experience and what I've seen people do is they integrate it very, very quickly together. Because technically it's a regular wallet, and you can do a bunch of stuff with it. You can add ENS, you can add push, like all that type of stuff. So not directly, but if you run into any issues with the integration, come to our booth. We have engineers to help.
Okay, thanks.
Yes. Oh, I'm done? Okay.
I have one more question.
What?
Sorry. For the EVM chains, do you have Circuit also?
Yeah, so EVM, that's a great question. I'll end with this. I'm sorry. EVM, and I'll answer your question after. The short version, any EVM chain you can integrate. It's either on our dashboard, or if you can't find it on our dashboard, go to our docs and look up custom EVM networks. You can add any EVM chain you want. So if it's EVM, should be good to go. Okay, very cool. Thank you guys so much. Yeah, perfect.
Hello everyone, my name is Daria and I'm a developer relations engineer at Neon. And today I'll show you how you can connect to Solana using Neon. So first let's go into what Neon is. We are a Ethereum virtual machine on Solana. So what that means for you as a developer is that you can take your existing Solidity code and just go ahead and deploy it with us. And then you can interact with your project using your favorite Ethereum tooling and specifically MetaMask wallet or any other EVM compatible wallet. So because we are running on Solana, we kind of combine the best of both worlds. So we have all of the benefits of Ethereum, so you don't have to change your code. You can use Viper or Solidity. You can use all of the well-known Ethereum tooling like MetaMask, Hardhat, Truffle, Remix, also anything ZK related. You can use the Ethereum RPC API and then also Ethereum accounts, signatures, and token standards like ERC 721 or ERC 20. And then we also bring in Solana benefits. Transactions on Neon are executed in parallel. We have low gas fees, high transaction speed, access to growing Solana ecosystem and liquidity, and also we use Solana consensus mechanism without any additional infrastructure or need for a sequencer. So we have been live on Solana since July 2023, and this is the overview of our tooling. So we have the EVM, the proxy server that acts kind of like an API. We have a tracer API for debugging. We have Neon Pass for sending tokens from Solana to Neon, and then we have the Neon Faucet for developers, and Neon DAO, which is the owner of the Neon EVM program. And the gas fees are extremely low, and we also achieve transaction speed of around 2,000 transactions per second. And this is Neon ecosystem. So as you can see, we have all of the standard EVM wallets available. So MetaMask, Trust Wallet, Wallet Connect. We use the same RPC providers as Ethereum. So P2P and Everstake. We have two explorers, Block Scout and Neon Scan. We support indexers like the Graph and Subsquid. We have NFT tooling, bridges, multi-sigs, and most importantly, we support all of the dev frameworks that EVM developers use. So Hardhat, Foundry, development platforms like ThirdWeb, and also Remix ID. And this is the overview of the dev tooling specifically. So as you can see, we support all of the Ethereum-specific tooling, also JavaScript libraries, OpenZeppelin standard, and so on. So this is the overview of Neon architecture. We have first, the user who interacts with Neon through a wallet. It can be Solana or EVM wallet. For example, MetaMask. MetaMask sends a transaction to a dev frontend, and then this dev frontend forwards it towards our proxy that acts like an RPC. And after that, the RPC forwards the Solana transaction to Neon EVM program on Solana, where the bytecode is translated into Solana instructions and subsequently executed on Solana. So this is the classic structure of a Solana program. You can see that it is different from Ethereum. It stores data in a different way. So you have separate accounts for your main account, then you have program-derived accounts, and you also have token accounts. So your tokens each have separate account. And now I'll show you how Neon uses this to support EVM. So this is the Neon EVM program. And as you can see, we use the free space that is allocated for data in the accounts to store some of the EVM information. So Solana allows up to 10 gigabytes, or megabytes, sorry. Solana allows up to 10 megabytes of storage, and Neon uses about 2. So in this way, we are able to put EVM bytecode, Ether address, nonce, balance, and all of the other relevant information into an account and then use it to execute the transaction. So this is how a Neon transaction is packed into Solana transaction program. We have an account list, and we utilize it to store a list of Neon accounts. Then in the program index, we store the index of Neon EVM program. And then in the data field, we store all of the Ethereum-like transaction data, like nonce, gas price, gas limit, value, and data. This is a diagram of how parallel execution works on Neon and Solana. So because of how Solana manages data and how it separates accounts and programs due to C-level execution, we can run parallel transactions also on Solana. So this is how we achieve the speed of up to 2,000 transactions per second. And another exciting feature is composability. So composability is the ability to use Neon EVM and call Solana transactions through your Solidity code. So this is an example of how it works. You have your Neon EVM account, which is represented through your, for example, MetaMask or any other wallet, and then you send an EVM transaction to a call Solana contract, which is an interface for a precompile inside of Neon EVM. So you call the execute function, and you can think about it similar. You can think about it kind of like a delegate call, where you pack your instruction, name of the function, and parameters that you want to execute, and gets forwarded to the precompile inside of Neon EVM program, and then forwarded to any Solana program that was marked as a destination in this execute function. And this is actually, I'm going to show you, and then it has functions like get resource address or get Neon address that can restore relevant information from Solana, and mainly the execute function, which you can use to call a specific instruction in any program on Solana. So this is a diagram of how transferring tokens from one account to another works on Neon. So in this case, we are transferring USDC coins using composability. So we own a Neon EVM account, and then we directly call Solana through the composability feature to send some tokens to Solana account. So you can see that we prepare an EVM transaction where we mark token program at the destination, and we want to call the transfer function. And we have a destination token, signer, source, and amount inputs. It goes to Solana precompile inside the EVM program, and then to Solana token program that owns the token program for USDC, and then they both handle the transfer from one token associated account to another. And I also wanted to show you one of the composability transactions. So this was a transaction sending some Solana from one Neon account to a Solana account using composability feature. So we can go into Neon Scan on our block explorer, and we will see that one transaction on Neon corresponds to two transactions on Solana in this case. And we can go ahead and open it. And we'll see that it was actually doing the sending. So it sent one sol from the account that Neon account owns to the destination account, all through just using Solidity code. And this is how it works. So you can use Hardhat and Web3.js to do this. You need to set up your transaction, get some information like public key, sender account, receiver account, and then you can just call the Solana instruction through Web3.js. And so in this hackathon, we have 2 tracks, and one of them is focused on composability feature. So the one that I talked about, so if you call Solana through Neon interface, you will qualify for this one. And another one is more meme coin and degen toolbox focused. So for this one, you don't need to directly interact with Solana through Neon. You can just use Neon EVM and deploy on it. And lastly, we have a little overview of how bridging and works from another EVML2 to Neon, and how bridging works, not bridging, but communication works between Neon EVM to Solana. So for example, if you're bridging tokens from Ethereum or Polygon, you have to use a bridge, which is the bridge in this case. And if you're sending tokens from Neon EVM to Solana, you can just use our Neon Pass, which essentially wraps tokens from Solana to be compatible with Neon, and then when you send them back, it kind of works vice versa. And then if you're building on Neon, you can join our developer resources. We also have GitHub, where you can see all of the examples of our code. If you want to go for one of our bounties in the hackathon, yeah, thank you for coming.
Thank you. Sorry, I was a little bit late, so I didn't see the contract for the Solana call. So there was the metadata, and I think, yeah, account meta. That's the account information from Solana?
Yeah, this is so on Neon, you as a user, you interact with your EVM account, but obviously the Neon program handles the creation of a corresponding Solana account that you own for you. And then when you use composability, you have to use the struct, where you essentially pass some Solana account information, especially if you're sending, for example, some SPL or SOL tokens from EVM account on Neon to another account on Solana specifically. So this is what it is for.
Okay, so, and again, I was late, but obviously you guys have this abstraction of paying the Solana gas using Neon, right? Or should I have some SOL on my account in Solana to pay for the gas?
So since Neon EVM is not an L2, and each of your transactions actually executes on Solana, you pay for gas in Neon, but the Neon EVM program handles the gas payment on Solana, so you do essentially pay for it. And actually, it is the same thing when you deploy a contract on Solana. Because of how the account model and rent works, it costs you kind of a little bit more, because we want you to pay for 2 years rent, so that your account is yours forever. You don't have to pay rent for it.
Oh, okay, perfect. Thank you.